Hello everyone, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all exams. Good evening all of you. Am I properly audible and visible to all of you? Please let me know once in the chat box. And guys, do share this session with all your friends and juniors, those who are going to appear for this GATE 2022 exam. Hi Chandan, very good evening. Yes guys, share the session and do like the session because we are going to have this important session for all of you. Yes, Kashif, I will be taking 3 subjects: digital logic, operating system, and compiler design. Good evening, Kirti. Good evening, Anant. Good evening, Kanchan. Good evening, Kaushalya. Good evening, Saubhagya. Good evening, all of you. Yes, guys, share the session as much as you can because this session is going to be really helpful for all of you because in just 3 hours, we are going to revise all the formulas for GATE Computer Science. So don't miss this session and do like it. Okay, that's good if you have already liked the session, and share as much as you can in all the WhatsApp groups and Telegram groups. Good evening, Raman. COA Anant will be taken by Satya sir. Good evening, Suhas. So the session is going to be like this: from 4 p.m. onwards to 5 p.m. I will be taking 3 subjects. Then from 5 to 6 p.m. Satya sir will join and he will be taking the other subjects, right? Programming, C, data structure, algorithms, COA, and the remaining subjects will be taken by Murli sir and he will join at this 6 p.m. Okay, yes, till 7 p.m. class will go. Okay, PDF, I will provide my subjects PDF in my Telegram group, so you can all join that group. Okay, so let's start guys. Without waiting, let me introduce myself. My name is Anshul Sharma. I have 2+ years of experience. In GATE 2020, I have secured All India rank 294, cleared ISRO and IELTS exam, mentored more than 1,000 students as of now, and these are my area of expertise. Okay, so this is my Telegram group link. You can join all. This is the link. You can take the screenshot as well, and later on you can join. I will be sharing the PDF of all my YouTube classes, doubt clearances. If you have any doubt, you can post your doubt there. Also, if you need any guidance, then also you are most welcome. Definitely, you will be getting the PDF in this group only, okay? For my set of subjects. Good evening, Aisha. Good evening, all of you. So let's start. And first of all, we are starting with a digital logic subject. Okay, so all the important things I will be discussing from all these 3 subjects. So if we talk about this 2 input XOR operation, we know basic stuff like AND, OR, NAND, NOR. These things we know, but there are some important things that we need to discuss in XOR operation. So if we talk about XOR, we know this, it acts like an odd number of ones detector in the input, right? It is mostly used in parity generation and detection. Sometimes a theoretical question can be asked, so you should know what will be the correct answer for this one, right? And we know when both the inputs are same, the output becomes low or logic 0. When both the inputs are different, then output becomes high or logic 1. Now this is very, very important formula because if you see the previous year questions, they have asked the questions indirectly and directly based on this. Okay, good evening all of you. Definitely after the class I will be sharing the PDF in my Telegram group, don't worry about it. Now here we know this A XOR B is also equal to A XOR B whole complement, right? And that is also equal to A complement XOR B and A XOR B complement. What about this one? We know this A XOR B, it is equal to A XOR B whole complement, and that is also equal to A complement XOR B and A XOR B complement. Clear? So this is very important. And the third point is, for odd number of inputs, XOR and XNOR are same. So whenever we are going to have odd number of inputs, like you can see this example, A XOR B XOR C, whenever the inputs will be odd, then both will be having the same result, whether it is XOR or it is XNOR. You can consider this example. And if you are going to have even number of variables, then they are complement of each other, like we can see here. This is very, very important property. Okay, so you should note this and also keep it in your mind, right? Now there will be some questions, like we have seen previous year question. In previous year you will see they will ask questions like you have to implement this function using minimum number of NAND gates and NOR gates, right? So this table is very, very important. If you want to implement NOT gate, right, then you need one NAND gate or one NOR gate. If you want to implement AND gate, you need 2 NAND gate and 3 NOR gates. If you want to implement OR gate, you need 3 NAND gates and 2 NOR gates, right? And similarly, if we talk about XOR and XNOR, which are the special cases, right? These two are the special cases, and here we need 4 number of NAND gates, 4 5 5 4, like this you can remember. And also keep this in mind, sometimes they will provide in the question that already the complements are available. If complements are available already, then in that case you may get less number of NAND gates or NOR gates, right? But if complements are not available, then you can use these in that question. Okay, so just keep this in mind. Complements when directly available, then you may get less number of NAND gates or NOR gates. Now if we talk about alternative symbol of gates, this is very, very important. Sometimes in the questions like decoder, they will provide you these gates. So there will be, if we talk about the first one, there will be one OR gate. Let's say 2 input OR gates are there. Let's say this is A and let's say this is B. If these are bubbled here, so this is equivalent to a NAND gate. It is equivalent to a NAND gate. Is it clear or not? Right? Similarly, if we talk about the second one, if you have bubbled a NAND gate, suppose you have a NAND gate here and you are giving A naught, and similarly here also it is bubbled. So this is equivalent to OR gate. This is equivalent to OR gate. You can try to simplify. And you will be getting the same thing. Similarly, if we have bubbled NOR gate, it will be equivalent to AND gate, and if we have bubbled AND gate, it will be equivalent to NOR gate. So sometimes in the questions of decoder, where you have to find out the minterms or the expression, there they will provide you these kind of bubbled AND gate or NOR gate. Then accordingly you have to solve the question, right? This is very, very important. So revise it properly and add it in your notes. Now if we talk about Boolean algebra laws, so we have identity law, right? So that is very easy. Distributive law is very, very important, because in simplification questions mostly we use distributive law or we use De Morgan's law. These two laws are most important if we talk about the simplification of Boolean expressions, right? So in distributive law, if it is A and B or C, so we can write it as AB or AC, and this is very important. If A or B, C, so we can write A or B. That means we are distributing OR operation over AND operation. So here it is A or B, right, and A or C. This is very important. Now if you talk about De Morgan's law, it is A or B whole complement will become A complement B complement. AB whole complement will become A complement or B complement. Is it clear so far? Now what about commutative law? So we know this, A or B is equal to B or A, and if we talk about AND operation, A and B is equal to B and A. What about associative law? This is also important. Sometimes they may ask whether which of the following does not follow associative property. So they will be giving you 3 to 4 options like AND, OR, NAND, XOR, right? So if I ask you, let's say if I ask you, you have 4 options, and if they ask you which one does not follow associative property, options are AND, OR, NOR, XOR. So what will be your answer? Yes guys, what will be your answer? Which one of the following does not follow associative property? AND, OR, NOR, XOR. Let's see how many of you will answer it correctly. Yes guys, quickly, I need the answer quickly. Let me write the options. Okay, We are getting the answer. So few students are saying NOR, few students are saying XOR, and the correct answer is NOR. So NOR and NAND gate, they don't follow associative law or associative property. XOR, that follows associative property. There is no problem in that. Revise guys, those who are answering incorrectly, revise these concepts. Okay, so associative, we know this. First we can perform B or C, and then we can perform A or B or C, right? Or we can perform A or B and then or C, right? So this is what associative law. Very good, all of you, those who are giving the correct answers. Now here also I have mentioned just for you, like NAND and NOR gates do not follow associative law but follow commutative law. Remember this. For these type of simple questions, don't waste your time in the exam. You should remember it. Okay, and this is not very difficult, right? Now what about this one? OR and XOR and XNOR, they follow both commutative property and associative property. So sometimes in the simplification also they may ask. In the previous year also they have asked these type of questions. Yes, Shiksha, Menti quiz. We will plan Menti quiz for CS students as well, right? And definitely, if we conduct that kind of session, it is going to be really interesting for all of you, and we will surely announce that if we are going to conduct any Menti session for CS students. So these are the laws. You should know it, right? Again, distributive, A or A complement will become 1, A or B. That is going to be the answer. Here also you can perform these simplifications. Now if I ask you the number of functions, now this is very, very important. Direct questions can be asked based on this. Clear? Now here, say this: if you have n variables, maximum possible self-dual functions, how many? This is the formula. First of all, you need to understand what is self-dual function, right? In order to understand self-dual function, you need to understand what is neutral function. What is neutral function? The number of min terms, when it is equal to number of max terms, then we call that function as neutral function. First condition, that if a function has to be a self-dual function, then first of all it has to be neutral function, right? Second condition is there should not be any mutually exclusive terms present, right, in the function. So these are the concepts. Now if I talk about self-dual function, first of all you need to have a neutral function. That means number of min terms will be equal to number of max terms, right? And what about the second condition? Mutually exclusive. That means you have to form the pair. So if you form the pair, how many pairs you will be getting? 2 raised to the power n combinations will be there. If you have n variables, 2 raised to the power n combinations, half of that will be the number of pairs. From every pair you can have one min term. From every pair you can have one min term. That means 2 choices are there for every pair. 2 raised to the power n minus 1 pairs are there. So 2 raised to the power n minus 1 number of maximum self-dual functions you can get. Is it clear? So along with the formulas, I'm revising you the concept as well, right? So you can either write like this one or this one. If I ask you what is the formula of number of neutral functions, can you tell me that? Anyone? Here I have not mentioned that. So can you tell me number of neutral functions if you have n variables? Let's see how many of you will answer it correctly. Yes guys, quickly respond in the chat box. How many number of neutral functions you can have if you have n variables? Quickly guys, quickly. Those who are worried about PDF, don't worry, I will be sharing the PDF. I have already shared the Telegram link. Okay, again after completing all the revision, I will be again sharing the Telegram link. You can join that. There you will get the PDF. Don't worry about it. Yes, quickly tell me number of neutral function. Guys, in neutral function you should have number of max terms is equal to number of min terms. If you have n variables, 2 raised to the power n combination, that means half of that will be number of min terms and number of max terms. So out of total you have to select half of it. So you can say 2 raised to the power n by 2, or you can write 2 raised to the power 2 raised to the power n minus 1. Yes or no? Yes, Nisha Kumari Barsha, you have answered correctly. Very good. Yes, hi Aman, Jai Shri Ram. Yes, Saubhagya, that is correct. That is correct. Very good, all of you. Let's see now number of Boolean functions formed over n Boolean variables. If you have n Boolean variables, how many Boolean functions you can form? If you have n variables, 2 raised to the power n combinations will be possible. Now, out of those 2 raised to the power n combination, each combination you can map either to 0 or 1, because we are talking about Boolean functions. You can map either to 0 or 1. That means you have two choices. So 2 raised to the power n will be number of Boolean functions if you have n Boolean variables. Is it clear? Now what about n valued variables? That means if you have n array variables, then in that case it is going to be 2 raised to the power n. Clear? So these are the direct questions that can be asked in the GATE exam for 1 mark. Okay, so don't get confused in this. Number of n valued functions. Now it is not talking about Boolean function, it is talking about n valued functions. So now if you have n Boolean variables, 2 raised to the power n combinations will be possible. Now you are talking about n valued functions. That means the function, that combination, each combination we can map to n values, right? So that's why it is n raised to the power 2 raised to the power n. Similarly, n valued variables, so it will be n raised to the power n raised to the power n. Is it clear so far? Is it clear so far? Now let's revise this half adder and full adder equations. You know the circuit, right? So this is the logical expression for sum and carry if we talk about half adders. If we talk about half adders, this is the equation. These are the logical expressions, and these are the logical expressions for full adder. Clear? For full adder. So sum equation of half adder is A XOR B, carry equation is AB. Sum equation of full adder is A XOR B XOR C, carry equation is this one. Either you can write AB or BC or CA, or you can write AB or CA XOR B. Why do we write the carry equation in this form? Why do we write the carry equation in this form? So that I can represent one full adder as combination of two half adders plus one OR gate. Yes or no, everyone? That's why I'm writing the carry equation of full adder like this. Is it clear? So one half adder will be equal to two half adders plus one OR gate, right? Now let's talk about the equations for logical expressions for half and full subtractor. So if we talk about the difference, so that is again A XOR B, but borrow will be different. So in case of half subtractor, it is A complement B. What about the difference? So the sum equation of full adder is same as the difference equation of full subtractor. Remember this, A XOR B XOR C. What about borrow? So borrow will be this equation. Either you can remember this one or you can remember this one. This is easy to remember, A complement B or A complement C or BC. Clear? Is it clear? So these are the logical expressions for half and full subtractor. Now let's talk about multiplexer. So here you have a 4x1 multiplexer. I have just written the characteristic equation of the multiplexer, because if you know how to write the characteristic equation, you can easily solve any question based on multiplexer. That is not a difficult task for you. So what will be the output? Output will be the, if we are selecting the select lines S1 complement S0 complement, I will be selecting I0, or here it is S1 complement S0, I will be selecting I1, S1 S0 complement, I will be selecting I2, S1 S0, I will be selecting I3. So this is the equation, characteristic equation of a 4x1 multiplexer. Clear? So you may get questions from multiplexer as well. That is also very, very important. Here I have not discussed what? I have not discussed that. What do we say? The number of multiplexers, right? If I want to implement, let's say, if I want to implement a 8x1 multiplexer using 2x1 multiplexer, can you tell me how many multiplexer do you need? Can you tell me how many multiplexer do you need? If I want to implement 8x1 multiplexer using 2x1 multiplexer? Yes guys, quickly. Yes, how many? That is very, very simple. There is one direct formula also, or you can follow the conventional way, right? In case of multiplexer, we consider the inputs. So two inputs, right? 2 inputs we can have in one multiplexer, 1 input we can have in half multiplexer. So 8 inputs, 8 by 2, that is 4 multiplexer. Then 4 inputs, 4 by 2, that is 2 multiplexer. 2 inputs, 2 by 2, that is 1 multiplexer. 4 plus 2 plus 1, that means 7 multiplexers I need. Yes. So remember this, whenever they are asking about implementing through 2 by 1 multiplexer, and if they give you 8 by 1, so just whatever is the number here, that means n minus 1 will be the number of multiplexers required. This is only valid when we are talking about 2 by 1 multiplexer, when we are implementing through 2 by 1 multiplexer. If they give you any higher number like 4 by 1 or maybe 8 by 1 for 128 by 1, then you have to follow this method. Got it? Then you have to follow this method. Okay, 7 is the correct answer. 3 will be the number of levels. Now what if we talk about decoder? Yes, 2 by 4 decoder. Demultiplexer, not at all important. That's why I haven't included that, because mostly from combinational circuits we get the questions from either multiplexer or decoder and the adders, right? These are the important topics. So in decoder we know this is enable, and here we know that select lines will act as the real inputs in case of decoder. If we are selecting a 0 0, I will be getting D0 as 1. If I will be selecting 0 1, I will be getting D1 as 1. If I select 1 0, I will be getting D2 as 1. If I select 1 1, I will be getting D3 as 1. This I'm talking about what? This I'm talking about active high decoder. This I'm talking about active high decoder. Right? You know the difference between active high decoder and active low decoder, right? A normal decoder where you are just getting the minterms out of it, so we can say that is active high decoder. What about active low decoder? Right? If you are using a bubble here, maybe you are using a bubble here, or you are taking a complement of that, in that case it is going to act as active low decoder. So in case of active low decoder, wherever you are getting 1, there you will be getting 0, and wherever you are getting 0, there you will be getting 1. I hope you know the difference between active high decoder and active low decoder. I hope so. There is no confusion regarding that. Okay. Yes, we use NAND gate there. Right. Now let's talk about ripple carry adder. So in ripple carry adder, we have the most important thing as the total propagation delay. Total propagation delay. So there is a direct formula for that. That is n minus 1. So if you are adding two n-bit numbers, so n minus 1 tc plus maximum of tc comma tsum. Maximum of tc comma tsum. This is the total propagation delay that you calculate using this formula, where tc is time taken to generate the carry. Time taken to generate the carry. And tsum is time taken to generate the sum. Is it clear? This is the formula. Total propagation delay is equal to n minus 1 tc plus maximum of tc comma tsum. This is the formula. Here I'm not going to explain you how we are getting it, because we are just revising the formulas only, right? Now if I talk about carry look ahead adder, so there the important thing they may ask is the number of NAND gates required, right, in the carry look ahead generator circuit. So number of AND gates will be n into n plus 1 by 2. N into n plus 1 by 2. This is the formula to calculate number of AND gates in carry look ahead adder circuit. And what about number of OR gates? What about number of OR gates? That is just n, where n is what? There, where n is number of bits we are adding. Number of bits addition we are performing between two numbers. That means the n bit is the number of bits. N bit will be the numbers, right? So n, to calculate number of AND gates, n into n plus 1 by 2. To calculate number of OR gates, it is just n. Clear? Now this is the diagram to convert the gray code or the binary number into a gray code. Binary number into a gray code. Yes, n is the number of bits present in the two numbers that we are adding, right? So here we are converting, let me write here also, we are converting binary to gray. So we know this G3 will be directly equal to B3, and then we are just performing the XOR between these bits, and whatever is the result, that will be G2, G1 and G0. This is how we perform the conversion from binary to gray. What about gray to binary? What about gray to binary? What about gray to binary? So B3, this G3 will be directly equal to B3, and then we perform XOR between B3 and G2, then we get B2. Then we perform XOR between B2 and G1, then we get B1. Then we perform XOR between B1 and G0, then we get B0. So this is the formula I have written here. This is for gray to binary conversion. Now let's come to sequential circuits. This is the characteristic table of SR flip-flop. So whenever S is 0, R is 0, what do you get? That is a case of hold state. Yes or no? That is a case of hold state. When S is equal to 0, R is equal to 0, that is a case of hold state. When S is 0, R is 1, that is a case of a reset state, because when we are giving R as 1, that means we are resetting the output. So that is reset. When S is 1, R is 0, that is a case of a set. And when S is 1, R is 1, that is invalid. That is invalid in case of SR flip-flop. Is it clear? Now what will be the equation? So this is the characteristic equation of SR flip-flop. How do we get here? So using this you can form the K map, and this X you can consider as don't cares. Then if you simplify it, what do you get? You will be getting Qn plus 1 is equal to S or R complement Qn. This is the characteristic equation of SR flip-flop. These equations you should remember, okay? So that in the exam, if you are getting any question based on that, so you should not waste your time in finding out the equation of SR flip-flop. Is it clear? What about JK flip-flop? So what is the change that we made in SR flip-flop to get the JK flip-flop? So what we have done here is S is equal to JQ complement and R is equal to K and Q, right? And this is the characteristic table. So when J is 0, K is 0, that is again the hold state. When J is 0, K is 1, in that case we get a reset, right? When J is 1 and K is 0, that is a case of set. And when J is 1, K is 1, that is invalid in case of SR flip-flop. But here in this case it is going to be toggle, or you can say complement, So toggle or complement mode will be there. Qn, this is Qn complement, right? Toggle or complement. So I hope you know this. And this is the characteristic equation of JK flip-flop. Again, using K map, we can get this equation J Qn complement or K complement Qn. This is the characteristic equation of JK flip-flop. Now let's talk about D flip-flop. So what we do in D flip-flop, whatever is the input D, we are going to give directly to J. That means J will be equal to D. And yes, Unnati, it is K complement Qn only. K complement Qn only, okay? Yes. Now here, in case of K, we are giving D complement, right? And we know this, in case of D flip-flop, if you are giving 0 as the input, you get 0 as the output. Why? Because if D is 0, J will be 0, K will be 1. If D is 0, J will be 0, K will be 1. That is a case of reset. So output will be 0. Right? But if you are giving D as 1, then J will be 1, K will be 0. That is a case of set. So you are getting 1 in the output. So that's why D flip-flop, we call it as a data flip-flop or delay flip-flop. Whatever input we give, we get that as the same output. That is D flip-flop, property of D flip-flop. And this characteristic equation, that is the proof of that. Qn plus 1 is equal to D. Right? Now what about T flip-flop? This is the characteristic table, and we know this. In case of T flip-flop, we directly give, this is J, this is K, this is a T input, we give the same to both J and K. So if T is a 0, J will be 0, K will be 0, that is a case of hold, right? Hold state. But if T is 1, J will be 1, K will be 1, so that is a case of toggle state. So here you can see if T is a 0, hold state. So if it is earlier, a previous output is 0, next output will be 0. previous output is 1, next output will be 1, because this is a case of hold. And when t is 1, it is going to be toggle. So 0, 1 here, 1, 0 here. So this is toggle. And based on this, we can find that the equation, characteristic equation of T flip-flop is nothing but T XOR Qn, right? T XOR Qn. This is the characteristic equation of T flip-flop. Guys, keep liking the session and share with your friends as much as you can, because this session is going to be really interesting for all of you. Let's talk about counters now. The most important thing in counters you get is these points related to ring counter. So in ring counter, why we call it as ring counter? Because the output of the last flip-flop we give as the input to the first flip-flop, that is ring counter. And we know this ring counter is a kind of synchronous counter. What is synchronous counter? Same clock pulse to all the flip-flops present in the counter. That's why we call it as synchronous counter. Now in case of ring counter, if you have n flip-flops present, it will be mod n counter always. Remember this point. These points are really important. Sometimes in some questions based on counters, you may use this point. Okay, now if n flip-flops are present, it will give you mod n counter. If input clock frequency is f, then output frequency will be f by n. That means whatever is the mod value of that counter, you have to divide the input frequency by that. Is it clear? What about Johnson counter, which we also call it as twisted ring counter? So in case of Johnson counter, the complemented output of the last flip-flop will be the input to the first flip-flop, that is Johnson counter. Here you can see if n flip-flops are present, then it will be mod 2 into n counter. If you have suppose 4 flip-flops present in twisted ring counter or Johnson counter, you will be getting mod 8 counter. What is the meaning of mod 8 counter? That means in the counting loop, in the state transition diagram, in the counting loop, you will be getting 8 states present in the loop. That is mod 2 into n counter. If input clock frequency is f, the output frequency will be f divided by 2 into n. That means whatever is the mod value of the counter, you have to divide it by that. Is it clear? Now let's talk about asynchronous counter. We call it as a ripple counter as well. So in case of ripple counters, if you have n flip-flops, then the mod value will be 2 raised to the power n, mod 2 raised to the power n counter. Is it clear or not? That means all the possible states will be present in the counting loop, and we know this as asynchronous counter or ripple counter. They are what? Free. They are self-starting and free running always. You know the definition of self-starting and free running? I hope you know this, right? So it will be mod 2 into n counter. If clock frequency is f, the output frequency will be f divided by 2 raised to the power n. So that is the output frequency in case of ripple counter. Now let's talk about the representations we have in number system. So we know this, if we have unsigned magnitude with n bits, the maximum value we can have in case of unsigned number will be 2 raised to the power n minus 1, and the minimum will be 0, because we are talking about unsigned. That means kind of positive numbers, no sign attached to it, right? In case of signed magnitude, what is the range? This is going to be the range minus of 2 raised to power n minus 1 minus 1 to plus 2 raised to power n minus 1 minus 1. Remember this, the range of signed magnitude and the range of one's complement number are same. They are same. There is no difference in between, right? Why? Here in case of signed magnitude and in one's complement number, good evening. In case of signed magnitude and one's complement number, there are 2 representation for 0. That is the disadvantage in case of these representation. That's why now we use only 2's complement representation, and here this is the range, very important. Minus 2 raised to power n minus 1 to plus 2 raised to power n minus 1 minus 1. Here you can represent one more negative number. That's why it is just minus 2 raised to power n minus 1. There is only one representation for 0. There are no 2 representation for 0, which we have in signed magnitude and one's complement form. Is it clear to all of you? So these are the ranges. That is very important. Now let's talk about overflow. The shortcut to overflow, I hope all of you know this. C out XOR C in. If it is equal to 1, then in that case it is going to be overflow. Now what is C out? What is C in? Let's say if I'm adding A3, A2, A1 with B3, B2, B1, I will be getting S1 here, S2 here, S3 here. So some carry will be generated here, let's say C2, some carry will be generated, let's say C3. Now this C3 will be your C in, right? And the carry generated by here, that is going to be your C out. That is, let's say C4, that is going to be your C out. So the carry given to the most significant bit will be your C in. Carry generated by the most significant bit, that will be your C out. C out XOR C in, if it is equal to 1, then it is, in that case, it is going to be overflow. Is it clear, everyone? If nothing is given in the question, always no. In that case, you have to consider 2's complement representation, because by default we are using that only. Okay, if nothing is given. Is it clear, everyone? Which counters are self-starting? See, self-starting means whatever is your initial state, irrespective of your initial state, if after giving few clock cycles, if you are able to, get into the counting loop, then you can say your counter is self-starting, right? I hope you know this. Okay, irrespective of initial state, that means you can choose any state as your initial state. After giving few clock cycles, if you are able to enter into the counting loop, then it is self-starting, otherwise no. Clear? So the formal definitions of overflow is that the conditions basically for overflow is, if you are adding two negative numbers and if you get a positive number, adding two negative numbers and getting a positive number, overflow. Adding two positive numbers and getting a negative number, overflow. These are the two conditions. And if you talk about shortcut, this is the shortcut to find out overflow. If you are adding, remember this, if you are adding a negative number with positive number, never ever you are going to have the overflow. I hope it is clear, right? Now let's talk about this floating point representation. If we are not talking about this single precision and double precision format, so this is the structure we use, this is the format we use, right? Bias value will always be equal to 2 raised to the power k minus 1. I hope you know this. We have the sign bit, here we have the exponent, here we have the mantissa. So we have the formula for explicit normalization where we have 0.m. This is the difference, 0.m, right? And we have the implicit normalization where 1 is already implied. 1 is already implied. That's why it is 1.m. Clear? Minus 1 raised to the power s, 0.m into 2 raised to the power e minus bias. That is the formula for explicit. For implicit, you have minus 1 raised to the power s, 1.m into 2 raised to the power e minus bias. How you calculate bias? Bias will be 2 raised to the power k minus 1. What is k? K is the number of bits present in the exponent. I hope it is clear. This structure, this format for representing floating points, I'm talking about for this one without without having this IEEE standard. But if you are having if you are following IEEE standard, mostly in the questions they will talk about single precision or double precision. So this is the format. In case of single precision, 1 bit for sign, 8 bits will be there for exponent, 23 bits will be there for mantissa. Okay, and if you have 8 bits, you know this, but the maximum number you can have using 8 bits will be 255. So this is going to be the range for the exponent in case of single precision, right? Register size will be 32 bits in case of single precision. Register size will be 64 bits in case of double precision. 1 bit for sign, 11 bits for exponent, 52 bits for mantissa. The maximum number or the range for exponent will be from 0 to 2047. Why 2047? Because the maximum number you can represent using 11 bits will be 2 raised to the power 11, that is 2048 minus 1, that is 2047. This is the IEEE defined format. And if we talk about the table for single precision, now how you can remember this? If e is 0, if exponent value is 0, if exponent value is 0 and m is equal to 0, then it is plus minus 0 depending upon the sign bit. If exponent value is 0 and it is m is not equal to 0, then it is fractional form. And what is the formula for fractional form? This is the formula, this is the given formula for fractional form, minus 1 raised to the power s into 0.m into 2 raised to the power minus 126. If e is equal to 255, if e is equal to 255, m is equal to 0, plus minus infinity depending upon the sign bit, whether it is 0 or 1. and if m is not equal to 0, then it is not a number. Nan means not a number. We don't represent these kind of numbers, right? And when e is lying between 1 to 254 and m is anything, mantissa is anything, then always it is implicit normalization form. For single precision, this is the formula for implicit normalized form: minus 1 raised to the power s into 1 point m into 2 raised to the power e minus 127. Remember this. In case of single precision, bias value will always be equal to 127. Is it clear, everyone? Is it clear to all of you? Any doubt? Anyone so far? Now let's talk about double precision. Again the same concept. You have to focus if e is 0. If e is 0, then see mantissa. If m is 0, plus minus 0. If m is not equal to 0, fractional form. What is the formula for fractional form? Minus 1 raised to the power s into 0.m into 2 raised to the power minus 1022. These are the standards that are defined by IEEE. We can't change them, right? We have to follow them. E is equal to 2047, E is equal to 2047, m is equal to 0, plus minus infinity depending upon the sign bit. M is not equal to 0, then again it is not a number. Nan means not a number. If E is lying between 1 to 2046 and m is anything, then it is implicit normalized form. Then it is implicit normalized form. Is it clear? Is it clear, everyone? So this is the table that you need to remember. Okay, so digital logic is covered. Now we are proceeding to operating system, guys. This is a formula revision class. So if you are having lots of doubts, that cannot be covered in this class. I hope you understand that. Okay, right. But still I'm trying from my side so that I can revise all the concepts for you related to the formulas, right? Now here, let's talk about operating system scheduling criteria. We know the formula CPU utilization, right? What is throughput? So most of the students, they get confused between the formula for CPU utilization and throughput. So what is the formula for throughput? Throughput formula will be number of processes that are completed per unit time. So number of processes, let's say n is the number of processes that are completed. That will be divided by the scheduled length. Now what is scheduled length? Scheduled length will be, let me write for you, scheduled length is equal to final completion time. That means the completion time of the last process, right? Final completion time minus first arrival time. That means whichever process arrived first, the arrival time of that you have to subtract from the final completion time based on the Gantt chart you have to see, and you have to calculate the schedule length. In this way you can calculate the throughput. Is it clear? Is it clear? In case of CPU utilization, right, or efficiency, you know how to calculate. Then you have to see whether there is any idle time for which your CPU is not executing any process. Accordingly you have to calculate that. What about turnaround time? Turnaround time is completion time minus arrival time. Waiting time is turnaround time minus burst time. Response time is first response time. First response time means first time CPU allocation minus arrival time. That will give you the response time. Is it clear, everyone? Yes, Kashif, I will be sharing the PDF. Don't worry about it. Now there is one more formula in case of HRRN. That is another a non-preemptive CPU scheduling algorithm. So here we calculate the response ratio. How do we calculate the response ratio? That is a waiting time so far. Okay, waiting time so far, right? Like if you are scheduling P1 process and then after P1 you are scheduling P2 process. So there is some waiting time. There is some waiting time. Okay, right. So now response ratio is waiting time so far plus burst time of that process divided by burst time, right? That is the response ratio. Now let's talk about paging. So there you have the formula, because in between you are not having any formula, right? Performance of paging. So if you are using single level paging without TLB, main memory access time will be M. Effective memory access time will be 2M. Why 2M? Because if it is single level paging, first you will be accessing the page table, then you will be accessing the main memory. We know this. page table resides in the main memory. That's why it is 2 into m. That's why it is 2 into m. Now here, paging TLB. If it is single level paging with TLB, in that case, let's say TLB access time given to you is C, and TLB hit ratio is also given to you, that means number of hits divided by total references. What will be the effective memory access time? That is going to be X, that means the hit ratio of TLB access time, and then main memory access time. Why we use TLB? So that we can reduce the effective memory access time, and TLB performs address translation, that is also being performed by the page table, right? So TLB stores the most frequently used page table entries. It performs the address translation. So that is hit ratio of TLB. If it is hit in the TLB, access time of TLB, then main memory to access that particular byte you are looking for. But if it is miss in TLB, in that case, first you have wasted some time in accessing the TLB, and then it is 2 into m, because there you will be going through page table for the address translation and then to the main memory. So this is the formula for effective memory access time. Is it clear? Now what if you are having multi-level paging? What if you are having multi-level paging? So in that case, effective memory access time, everything is same, just the difference is of n plus 1, where n is the number of levels of paging. In case of single level, you know, it is going to be just one. It is going to be just one page table. But if you are having more than one, right, multi-level paging, so n is the number of levels in paging. So n plus 1 into the main memory access time. That will give you the effective memory access time. Is it clear? Is it clear to all of you? Yes, Abhage, final completion time if IO is there. See, after completing the execution of all the processes, if it is performing input output, you don't have to consider it. Okay, final completion time will be when the burst time is completed. Got it? When the burst time is completed. Right, now let's see some formulas for paging here. Logical address space, we know this, we divide it into equal size pages. Page size is in the generalization of power of 2. It always exists in the power of 2, like 4 KB, 8 KB, etc. And number of pages, how do you find number of pages in logical address space? That will be logical address space divided by the page size. So you get number of pages in the logical address space. What about page number bits? What about page number bits? How do you find page number bits? So the number of pages you have evaluated, just take the log of that and take the seal of it. So you will be getting page number bits. Page offset depends on the page size, right? Suppose your page size is, let's say page size is 8 KB. So what will be the value of page offset? That is, it is equal to 2 raised to power 13 bytes. So 13 bits will be there in page offset, and that is the same thing I have written here. Is it clear? Now let's talk about physical address space. Physical address space is divided into equal size frames, right? We have the main memory, we divide it into equal size frames. We know this frame size is always equal to page size. Number of frames is equal to what? Physical address space divided by page size or frame size, because both are equal. Frame number bits, you first calculate number of frames. To that, just take the log of it and take seal of it. You will be getting frame number bits. What about frame offset? What about frame offset? So first you find the page size, you have the page size. Through page size, you will be getting page offset. That is also same as frame offset. Is it clear, everyone? If you have any doubt, please ask. Now let's talk about virtual memory concept when we are having the concept of page faults, right? When page fault is there. So how do we calculate effective memory access time? So here we are just considering the page fault concept. Effective memory access time will be P, suppose P is the page fault rate. So 1 minus P will be page hit ratio, right? And let's say S is page fault service time. Remember here, if the units are different, if the page fault service time and the main memory access time, if it is very, very large than the main memory access time, we are going to ignore here S plus M. We are just going to write the page fault service time. So if in the question, if the units of page fault service time and the main memory access time, if they are different, let's say M is given in millisecond and let's say S is given in microsecond or maybe nanosecond, in that case we can ignore the value of M here. We are just going to write if there is a page fault, page fault service time. If there is no page fault, then we are directly accessing the main memory. I hope it is clear to all of you. So based on the unit, if units are same, then don't ignore m here. You have to add s plus m. You have to do s plus m, but 99% of the time you have to ignore main memory access time here. It is just going to be page fault, then just page fault service time. Clear? So OS is also complete, and now we are heading towards the last subject for, I will be taking this compiler design, and then after that other faculties like Satya sir will join and he will be taking his subjects, and then Murli sir. Okay, so this is my last subject. Okay, you just keep on attending the session and get the benefit of it. Now in compiler design we talk about left recursive elimination. So how we can do that? If we have a derives a alpha or beta, so how you can eliminate this left recursion? So this is the non-left recursive part, beta is the non-left recursive part, so I can write beta here and then write just a dash. Now in this left recursion here, this is the remaining portion, alpha is the remaining portion, so write a dash derives alpha, a dash or epsilon. So first you need to find out the non-left recursive part, write it here, then a dash, right? You can use x, y, z, whatever. Here I'm using a dash, then a dash will drive what? The remaining portion where you have the left recursion, that is alpha, alpha, a dash or epsilon. Is it clear? So this is left recursive elimination. Now let's talk about left factoring. That means common prefix problem. If you have common prefix problem, so we eliminate that. It is also called as elimination of non-determinism present in the grammar. So now if you have this a derives alpha beta 1 or alpha beta 2, how you can eliminate common prefix problem? Here you can see alpha is common. Here you can see alpha is common. So we can write alpha here, just whatever is common, take it outside and then write a dash. Now this a dash will drive what? The remaining portion. So you have beta 1 or you have a beta 2. So this is what we do as what we do in a left factoring of the grammar. So this is left factoring, very, very important, right? Now if we talk about LL1 grammar, how we can check whether a given grammar is LL1 or not? So there are some shortcut, or there is some theory as well, right? Now here if you see, to check whether given grammar is LL1 or not, let's consider these two cases. Here in the first case you have a derives alpha 1 or alpha 2. So if you have these, then first of this one alpha 1 intersection first of alpha 2. If you have anything common, then it is not LL1. If you have nothing common between these two, then that means the intersection will be 5, so it is LL1. That's what it is written here. In the second case, if you have suppose a derives alpha or epsilon, that means a is also deriving epsilon. In that case, first of alpha intersection, if you have epsilon, then you have to calculate follow of left hand side. So follow of a is there. Take the intersection. If anything is common, it is not LL1. But if nothing is common, it is 5, then it is LL1 grammar. Is it clear? Now there are important points written here. A grammar when it is LL1 parsing table has to free from multiple entries. So this point is related to the table construction. There we check whether we have the multiple entries in a single cell. If we are having multiple entries in a single cell, then it is a conflict. And when we are having a conflict, we say the grammar is not LL1 if we are having multiple entries in the single cell. These are the most important points related to LL1 also. If the grammar is left recursive, clearly you can say it is not LL1. If a grammar is not left factored, that means common prefix problem is present, then also you can say it is not LL1. And if the grammar is ambiguous, then also we can say it is not LL1 grammar. These are the most important points related to LL1. Let's come to the bottom-up parsers. So in bottom-up parsers, we know we have shift reduce parsers. Like we have LR parsers and we have operator precedence parser, right? So in case of LR parsers, we have 4 parsers: LR0, SLR1, LLR1 and CLR1, which we also call it as LR1. Now how we can check the conflict in case of LR0 parser? We have 2 types of conflict: shift reduce conflict and reduce reduce conflict. If in a single state, that means in the same state, if you are shifting on a terminal, here you are shifting on X, which is a terminal, and you have a reduce item present, then you can say SR conflict is present. If any of the conflict is present, clearly you can say this is not LR0 grammar. This is not LR0 grammar. What about the next conflict? RR conflict. If you in the same state in the DFA, if you are having two reduce item, then also we can say RR conflict is present. As you can see in this example, A drives alpha dot, B drives gamma dot. Both are reduce item, right? What is reduce item? Dot is present at the end, so that is a reduce item. If dot is present in between, we call it as shift item. If dot is present, in the beginning, then we call it as state item. So there are some concepts there. But if you talk about RR conflict, if we are having more than one reduce item in the same state, RR conflict is present. It is not LR0. Clear? What about simple LR1, which we also call it as SLR1 in short? How we can find the conflicts? Again, conflicts are same, SR conflict and RR conflict. But in case of SR conflict in SLR1, if you have in the same state, if you are having a shift move on a terminal and you have a reduce item, then how to check SR conflict? Wherever you have the reduce item, find the follow of left hand side. So follow of B intersection, if you are having that terminal, or in simple words you can write if X belongs to follow of B. Simple. If X belongs to follow of B, that means X is there in the follow of B also. Intersection is not equal to phi. Intersection is not equal to phi. In that case, SR conflict will be there in SLR1. What about RR conflict, reduce conflict? A drives alpha dot, B drives gamma dot. Both reduce items are there. How to find RR conflict in SLR1? Find the follow of both left hand side. Follow of A intersection follow of B. If the intersection is not equal to phi, RR conflict is present. If it is equal to phi, RR conflict is not present. In this way, we can check the conflicts in case of SLR1. Now, what about LR1 parsers? If we are talking about LALR1 and CLR1, so we know this, the conflicts, how we check the conflicts like SR and RR, that is same, right? How we check the conflicts, the method is same, but there are some certain important points that you need to understand here. First, let's talk about conflicts here. SR conflicts, if in the same state, right, there is a shift on a terminal, that is X. As you can see, dot X is there, so there is a shift on a terminal X, and there is a reduce item. Now in the reduce item, if that X belongs to the look-aheads of the reduce item, that means this X is also present in the look-aheads of the reduce item, then it is SR conflict. What about RR conflict? So here you have two reduce items, and if you have anything common between the look-aheads of the two reduce item, then it is RR conflict. In this way, we can check the RR conflict in case of CLR1 as well as in LALR1. Now there are some certain important points that you need to understand here. First, we make the CLR1 diagram, and then we find out whether we can merge any of the states. If merging is possible, then we can form the LALR1 diagram. Otherwise, LALR1 diagram will be same as CLR1 diagram. If no merging is possible, both diagrams will be same. But if merging is possible, then we are going to merge the states, right? And this is the very, very important point. If you are not having SR conflict in case of LR1, you will not be having SR conflict in case of LALR1. Remember this point. Many times they have asked in the GATE exam also. It can be asked again as well in MSQs. Right? So if there is no SR conflict in LR1 or CLR1, there will be no SR conflict in LALR1. But this is not true with RR conflict. If you are not having RR conflict in case of CLR1, you may or may not have RR conflict in case of LALR1. So why I'm saying so? Because after merging, it is possible that you may get the common look-aheads in the two reduce item. That's why RR conflict may or may not be present. Is it clear? Is it clear everyone? LALR कब नहीं होगा? Akansha, if in CLR1 you are not having SR conflict and you are not having RR conflict, But in LALR1 you are having RR conflict, then it will not be LALR1, it will be just CLR1. Getting the point? So these are the important points. Here I have written every LALR1 grammar is CLR1, right? Because this is a subset of CLR1. But every CLR1 grammar need not be LALR1. Fifth point is LALR1 parsers. So in practical usage we use LALR1. Why? Mostly uses LALR1 because the size of the table is smaller as compared to CLR1 parser. Now if we compare the parsers, this is in terms of power, right? We know in case of LR parsers, CLR1 is the most powerful. Then we have LLR1, then we have SLR1, then we have LR0. This is the order of power. And this is the order of number of states we have. Number of states in LR0 is equal to number of states in SLR1 is equal to number of states in LLR1. And that is less than equal to number of states in CLR1. Okay. Remember this. This is also very, very important. This is the most important diagram in case of these bottom-up parsers, right? And here you know this LR0, then you have SLR1, LLR1, CLR1, and then unambiguous grammars. That means we are having some unambiguous grammars which cannot be passed by any of these LR parsers, right? And we have ambiguous grammars also. So we have operator precedence parser. We know this operator precedence parser. It can parse some of the ambiguous grammars, not all. Some of the ambiguous grammars can be parsed by this operator precedence parser, and some unambiguous also it can parse, right? And here we have the LL1, right? Here we have the LL1. You can compare, but we can say LL1 will be less powerful than these LR parsers, bottom-up parsers, okay? But we generally don't do it. So LL1 here we can represent. If a grammar is LL1, definitely it will be CLR1. Why I'm saying so? Because it is a subset of that, right? It is a subset of that. LL1, if grammar is LL1, definitely it will be CLR1. As you can see, it is a subset of that. So that's it, guys, from my side. I have completed 3 subjects revision. This is the Telegram group. You can take the screenshot and join Telegram group to get the PDF of these 3 subjects. Other subjects PDF will be shared by the rest of the faculties. Now I would like to invite Satya sir to continue this session, and just students are waiting for him, right? All the interesting subjects like C programming, data structure, algorithms, and COA. So that will be taken by Satya sir. So I would like to invite Satya sir now. Yes, Satya sir, you can take it forward. Thank you all. Thank you for joining this, and keep attending and keep sharing the session. Now Satya sir is going to join and he will continue the session. Thank you all.
Hello everyone, very good evening one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep. And warm welcome to the session again. I hope you are all enjoying the session. Anshul sir has covered 3 subjects formula session. I think digital logic, operating systems, and compiler design. These 3 subjects formulae were given by Anshul sir, I think in a very effective manner. Thank you, Anshul sir. So, good evening all of you. Chandan, Kaushalya, Suhas, Divyansh, Pooja, Siksha, everybody. How are you all doing? Very excited? Yep. Great. So guys, Anshul sir has already covered 3 subjects revision, formula revision, and I do continue this session hopefully with the same interest. Before that, this is quick brief about me, as some of you might be new or some of you might have forgot. So I am Satya with 14 plus years of teaching experience, and I have mentored more than 30,000 students, qualified in GATE, SET, and certified by Cisco. Right? Yeah. And guys, keep liking the session, keep sharing the session. This is the unique session on BYJU'S exam prep and on compared with all the other platforms. So please do invite your friends for this very, very unique and useful session. Right. So guys, I will be covering 3 subjects. They are programming and data structures, algorithms, computer organization, and architecture. These are the 3 subjects. I will be covering the formulas of these 3 subjects. And I believe you people know programming, data structures, and algorithms together. These 2 subjects together, you will get 15 plus marks. And from computer organization and architecture, you can expect around 6 to 8 marks. So with these 3 subjects, you will be able to get minimum 21 to 23 marks, right? So let us first start with programming and data structures. As you all people know, you are preparing since 1 year or 6 months rigorously for the GATE exam. By this time you have already realized, I think so, that we have very less formulae compared with other branches. So not only formulae but also some very, very important points we will try to cover, which will help you for preparation of your short notes for the last minute revision, right? Before I take you in, could you please confirm, am I visible and audible to all of you? Everybody please confirm, and also keep liking the session, keep sharing the session, guys. Try to invite all of your friends, whoever are aspiring for the GATE exam, through WhatsApp, Telegram, Twitter, Insta, Facebook, everywhere. Try to share as much as possible. Okay. All fine. Great. So guys, first let's see what are very, very important to know in programming and data structures. Firstly, arrays and pointers. If I talk about, it is very, very confusing for many students, this convention. Individually, array means everyone understand, pointer is very well understood. But when we try to combine these two, then a confusion comes. So here I would like to break that confusion. Suppose A is the array and P is the pointer, I be the index, let us suppose. If so, whenever you say A of I or P of I or I of A or I of P, all these 4 means same. All these 4 refer to what? Value. Whenever you say A of I or I of A, P of I or I of P, that will give you value. In the same way, wherever you see A plus I, provided A is 1D array, or I plus A, similarly P plus I or I plus P, what you get? Address. What address? Address of ith element. Here, value of ith element. Okay. So this is for one dimensional array. But for two-dimensional array, it is little different. When you say a plus I, we know you will get address, right? But for a two-dimensional array, which is combination of collection of one-dimensional arrays, when you say star of a plus I, which is value at ith row, you don't have just one value, you have complete row. So what you will get when you use star of a plus I, you will be getting address of ith row. So for 2D array, a plus I star of a plus I will give you address only. In the same way, if you find some I and j, let I and j be row and column indices. If you find star of a plus I plus j, then what do you get? Star of a plus I means ith row address plus j means in that row jth column address you will get. So you will get what? Address of ith row jth column. And if you find star of a plus I plus j, that means that is directly you can say simply a of ij, value of a of ij. So if you know this, even some complex question also you can easily trace and easily answer. Is this clear? Any doubts in this? If so, please feel free to ask. Everybody, whoever are watching it. Somehow, definitely through the Telegram group, I will be providing. Okay. Right. Now, with respect to arrays, we know how to find the how to retrieve the value, but how to find the address? And we know the index may start from 0 or 1 in the arrays. If so, if it is for 1D array, let B be the base address and X is the array name and N is the size of one element. If so, how do you get address of X of I? B plus I into N if the index starts from 0 and B plus I minus 1 whole I minus 1 into N if index starts from 1. This is how you can retrieve address of any element if it is one-dimensional array. And if you take two-dimensional array, 2D array can be saved in the memory in two ways. We say row major order, column major order. Row major, column major means row wise if the elements get stored, we call it as row major, column wise column major. So if index starts from 0 in the RMO row major order, how do you get address of ij? Here is the formula: B plus I into C plus J whole into N. Here what is the C? C is number of columns. R is number of rows. And what is I? Row index. And what is J? Column index. If it is column major order, instead of I into C, we use J into R. Instead of J, we do plus I. If index starts from 1, in the place of I, we use I minus 1. In the place of J, we use J minus 1. Simple. Sir, do we get questions calculating addresses in the GATE exam? I cannot say you don't get or you will get. But this formula may help for finding the output of the given program. You may get some program seeking the output for with arrays and pointers. There it may work. Okay. Durgesh Nandan, already on our BEP BYJU'S exam prep platform, full courses are happening in which I am taking some subjects. So do join BEP if you want full course, Durgesh. Right. Then in the data structures, programming data structures, majorly what we can have is some formula from trees. Linked list stack, what queues. We don't have specific formulae, as I believe you all people know, right? We don't have a specific formulae, but yes, we have types of linked list, types of queues, how we implement them, how you find the overflow condition, underflow condition. Like that, we do have certain parameters or certain points in that. But when I say formulae, definitely we have to switch to trees. Saubhagya, hold a minute. So in trees, most importantly, I can say some formulae are like if the number of nodes in the perfect binary tree at level L, at level 0, at level 1, at level 2, at level 3, like at level L, it is 2 power L, 2 raised to L. If the level numbering starts from 0, it is 2 raised to L minus 1 if the level numbering starts from 1. Similarly, the number of labeled binary trees, the number of labeled binary trees with n nodes. Okay. Labeled should be multiplied by n factorial. Okay, wait, let me, I think it is just exchanged while typing. Just give me a moment. This should be unlabeled and this should be labeled. Yeah. So the number of unlabeled binary trees, the number of unlabeled binary trees with n nodes is 2n divided by n plus 1, and the number of labeled binary trees with n nodes would be 2n by n plus 1 multiplied by n factorial, because everywhere you can have any node, right? If you say A, B, C are the nodes, A can be the root, B can be the root, C can be the root. A can be left child, B can be left child, C can be left child. Similarly, A can be right child, B can be right child, C can be right child. In that way, if you take combinations, you will get n factorial combinations. Right? Then, For a binary tree with n nodes, if there are total n nodes, then what is the maximum height possible? N minus 1. Minimum height possible? Log n plus 1 base 2 minus 1. Yep. Whole. It is whole only. 2n cn divided by n plus 1 whole into n factorial. So where do you get maximum height? You will get maximum height in skewed binary trees. If it is a left skewed or a right skewed, in some skewed binary tree you will get maximum height. And where do you get minimum height? In the perfect binary tree you will get minimum height. The same in reverse. For a binary tree with height h, if we got height h, then minimum number of nodes would be h plus 1. Where do you get minimum number of nodes? In the skewed binary tree. And the maximum number of nodes would be 2 raised to h plus 1 minus 1. So that is, in perfect binary tree, you will get maximum number of nodes. Then, the number of nodes with exactly 2 children with total x leaf nodes. In a tree, let's say there are x leaf nodes. Then in that tree, how many nodes will have exactly 2 children? X minus 1. You can check. You can just check something like this. Here there are 3 leaf nodes. And how many nodes have exactly 2 children? 1, 2. Right? So, in programming data structures, majorly we have these pointers, arrays and trees which are comprising of formulae. If you talk about time complexity, yes, that I'll show you in algorithm subject. Okay? So quickly let us move to algorithms, where undoubtedly in algorithms, which is very important. Of course, all are important, but if you look at the frequency, definitely you should focus on recurrence relations or their solution. So one best way to solve recurrence relation is master theorem. So definitely every one of you, I recommend, please learn master theorem because it saves lot of time in the exam. As you know, GATE is a competitive exam which helps all over India. So speed is definitely required and time management is very much required. So master theorem could save lot of time. So master theorem, where you have exponential decrease in the input size. If we have exponential decrease in the input size, then we have these cases. So if you get a recurrence relation of the form A into T of n by B plus theta of n to the power k log to the power p n. If you have any recurrence relation of this form, provided these constraints are satisfied, then we will compare a and b to the power k. So three possibilities. A can be greater than b power k, equal to b power k, less than b power k. When a is greater than b power k, simply you can say the time complexity is theta of n to the power log a base b. If a equal to b power k, we have three subcases. P can be greater than -1, equal to -1, less than -1. If it is greater than -1, then it would be theta of n to the power log a base b log to the power p plus 1. Here it is not log p, it is log to the power. Log to the power p plus 1 n. And if p value is -1, then you can see it is n log a, n to the power log a base b log n. And if p is less than -1, then it is theta of n log a base b, n to the power log a base b. Shiksha, परफेक्ट फुल एंड कंप्लीट बाइनरी ट्री डिफरेंस बता दीजिए जरूर। शिक्षा, फर्स्टली फुल बाइनरी ट्री मीन्स it should have either 0 or 2 children for any node. So suppose if I take this, it is full binary tree because A has 2 children, B 0, C 2, D and E 0. So every node is having either 0 or 2 children. So it is full binary tree, but it is not complete, it is not perfect. Why? Perfect binary tree says it is full and leaves should be at the same level. Here B at one level, D and E are at another level. So it is not perfect, it is not complete, but it is full binary tree, right? And if you take something like this, or even you can extend to this, here it is complete binary tree except leaf level, other levels are completely filled, may or may not be completely filled. But you see, it is not full binary tree. Why? C has one child only. No node can have one child. And it is perfect? No, because it is not full, it is not perfect. So every perfect binary tree should be full binary tree first. So if you take some tree like A, B, C, D, E, F and G, here it is perfect binary tree, complete binary tree, also full binary tree. Okay, Shiksha? Right. So in the master theorem, if the input size decrease exponentially, we will compare A and B power k. Accordingly, we get three cases. Then for case 2 and case 3, we have sub cases. Accordingly, we can directly write what is the time complexity. But always input size need not to be decreased exponentially. Then what? Then there can be linear decrease also. Here input size n value is decreasing linearly, n minus b. Then with these constraints satisfied, we only check a value. A can be equal to 1, greater than 1, less than 1. Accordingly, you can say The time complexity is f of n into f of n, or f of n into a to the power n by b. So guys, I recommend everybody please do learn this master theorem, because it saves a lot of time in the exam. Great. Now, time complexities is one of the most important, most occurring, most expected question. Definitely you will see minimum 2-3 questions in every year gate paper asking for one or the other time complexities. So here I am presenting all the time complexities for you. First, what are different time complexities and what we call them as? Different time complexities, popular time complexities, you can say constant time complexity, which is represented as big O of 1, logarithmic, log squared, linear, quadratic, cubic. These you can say polynomial also, so for some n to the power I. So n square, n cube, n power 4 you can say polynomial commonly. N square you can say quadratic, n cube cubic, in that way. And exponential time complexity. So which is bigger, which is smaller? Here, as you go from top to bottom, it is bigger. Means small, a constant time complexity is very small, and exponential time complexity is big. And we have many type of searching algorithms, but in our syllabus we just learn these linear search, binary search, depth first search, and breadth first search. So their time complexities are like n, log n, v plus e. Here what is v and e? V is number of vertices and e is number of edges in the graph. At least these 4 you have to focus on. Other time complexities though you don't learn, that's okay. Sorting algorithms time complexities, definitely it is must and should to be learned one, because directly you will get question. Many times it is there. What is the worst case time complexity of quicksort? What is the best case time complexity of insertion sort? Or the time complexities of XYZ sorting techniques are respectively what? Like that, there are many instances where you got direct question on time complexities. So please learn this, refer this frequently. So for bubble sort, in every case the time complexity you can see is n square, and even selection sort n square. And there is some advanced bubble sort which stop the process if by detecting if the list is already sorted. There you can say the best case time complexity is big O of n. The other time complexities is still n square. And insertion sort time complexity, definitely Chandrasekhar, definitely in the Telegram group I will be sharing the PDF of my 3 subjects. Okay. For insertion sort it is big O of n in the best case, and the other cases it is n square. Heap sort, merge sort have same time complexity. Heap sort and merge sort have same time complexity in all the cases. What is that? N log n. And quick sort In best and average cases, it is n log n, and in the worst case, it is n square. In this, which is stable, which is unstable? What sorting techniques are stable? What sorting techniques are unstable? What is the difference between stable and unstable? Suppose if you have some duplicate elements, then their relative position should be preserved. Like you have two threes or two numbers with the same value in the list to sort, then in what order they have occurred, in that order only throughout the sorting procedure, the same order should be preserved. If so, you call it as stable, otherwise unstable. So what are stable sorting techniques? What are unstable sorting techniques? You can easily remember with some code, guys. I think many of you people know it already. However, let me give you IBM for stable, SHQ for unstable. Just remember stable IBM, unstable SHQ. I means insertion sort, B means bubble sort, M means merge sort, are said to be stable sorting algorithms, and selection sort, heap sort, quick sort are said to be unstable sorting algorithms. So just remember these codes IBM, SHQ. Okay. Then the time complexities of all the data structures or most required data structures here I have presented. Of course, AVL tree, we have never got any question in the gate for CS, but still every time it is anticipated. So just go through these time complexities. Observe this. Array insertion and deletion time complexity is big O of n. Don't get surprised by seeing this. Yes, because array permit random access. But if you want to insert or delete, you know array has a static memory allocation. If you want to insert somewhere in the middle as last but one location or so, you might be thinking, what is there? I'll say a of n minus 1 is equal to value. So it takes constant time. But imagine the worst case scenario. We already have some list and we want to add some more elements to the list. Array permits only static memory allocation. So you might need to adjust the elements. Similarly, deletion from the array, it is actually logical deletion or assumed to be deleted. Really, it is not getting deleted. Think once. Though you just move the index, but value still be there. If you want, you can just try printing the values using array. After you assume to be deleted, after that also you try to print the values, they will be there. In place only merge sort. Sorry, in place except merge sort, all the others are in place. Only merge sort is external sorting algorithm. Okay. And in some scenarios, heap sort we treat as external, but mostly if you need to pick only one, merge sort you can pick for external sorting algorithm. Other than that, all other algorithms you can treat as in place. So guys, from the array, let's say you have deleted some middle element. Is it really getting deleted? No. If it should be get deleted, what you should do? You should overwrite either with the left elements or with the right elements. So insertion and deletion takes big O of n time for an array. Remember. And you can just see the other data structures time complexities. There is a possibility to get a direct question asking these time complexities. Okay. Then in the algorithms, we know we have 5 major paradigms of algorithm design as dynamic programming, greedy, divide and conquer, backtracking, branch and bound, excluding the brute force method. But in our GATE exam, we have only 3 paradigms. One is DP, other is greedy, other is divide and conquer. So I will present some popular DP applications and their time complexities. Similarly for the other paradigms also. So first is a subset sum problem whose time complexity is big O of 2 raised to n. Then 0-1 knapsack problem whose time complexity is n multiplied by w. Here what is n? N means number of items. What is w? Knapsack weight. So it is proportionate to knapsack weight and number of items. And Bellman-Ford algorithm, which is also called single source shortest path problem. For that, the time complexity is big O of v into e. If you take a complete graph, for a complete graph, then it would be big O of n cube. Because edges would be n into n minus 1 2 edges for n vertices. So that would become n cube. And Floyd-Warshall algorithm, which is famous as all pair shortest path problem. This is also DP based application. Its time complexity, MCM, matrix chain multiplication time complexity, and also OBST time complexity is cubical. Right? And what are different greedy applications? Some popular greedy applications. Here you can see job sequencing with deadlines, that is n square time complexity. Huffman coding, n log n. Prims and Kruskal's e log v or e log e. Distra, e log v or e log e. Here, if you take the complete graph, still it would be big O of n square log n, but it would not be n cube. Even if you take worst case, it would be just n square log n or asymptotically n square, but not n cube. So time complexity wise, this throw is better than Bellman-Ford algorithm, but this throw has a drawback. If we have any edge with negative weight, then this throw may fail. And this throw doesn't guarantee optimal solution, of course, because it is based on greedy. And traveling salesperson problem, n square into 2 raised to n, and fractional knapsack n log n. Then, yes, good Deepak, very good. Then divide and conquer applications. Merge sort, quicksort, binary search, towers of Hanoi. These are popular divide and conquer applications, dear friends, dear students. So don't miss them. The time complexities. I am giving the worst case time complexities. Okay. And Strassen's matrix multiplication, big O of n cube. Here actually you can say it is big O of n to the power 2.891, something like this. Using Strassen's method, we will reduce it to 2.891. And finding missing number in the AP, that is log n, arithmetic progression. Okay. And I am trying to present some very important recurrence relations also for the worst case, because sometimes these are also asked in the exam. Majorly quicksort, merge sort, recurrence relations you see, it is 2t of n by 2 plus big O of n. And for binary search it is t of n by 2 plus big O of 1. And binary tree traversal, this is 2t of n by 2 plus big O of 1. So I tried to present some recurrence relations of most popular or mostly asked algorithms. So please try to refer, try to keep this in your short notes before you go for the exam. Please do refer it. Okay. So these are what important to revise. You can consider them as formulae, or you can consider them as LMR points, last minute revision points from algorithms. Then let us switch to the subject computer organization and architecture. Yes, compared with other, this is theoretical. Definitely we have certain number of formulae, and very interesting subject, guys. It's one of my favorite subjects, COA. Guys, though we say its weightage is some 6 to 8 marks, but there are some cases, there are years where you got even 13 marks also from this subject. So do not underestimate it. Sometimes you got more than programming data structures, more than every other subject, you have got weightage for this subject. So it may recur in 2022 GATE, who knows? But on an average, we were telling definitely you can expect around 6 marks minimum. There is a potentiality for this subject even to scale up to 13, 14 also. COA is toughest. It's actually a myth. It completely depends on your level of preparation, your level of understanding. Okay. But it is little theoretical compared with other subjects. That is what the problem. That's what it differs from one to one, whether it is easy or toughest. Okay. So let me present what are important points or important formulae of this COA. Firstly, very important is cache mapping techniques. While you are solving the previous year questions, I think you might have realized this. 95% of the cases you will have a question on this cache mapping techniques, right? So if you take, so I am presenting the summary of this cache mapping techniques here for you. We know we have 3 different mapping techniques: direct mapping, associative mapping, set associative mapping. If it is a DM cache, how it interpret the CPU generated address as a tag, line offset, word offset. Here what line means? Line, block are synonyms. And what is maintained as a tag by DM? It maintains the page number of main memory. Here page number means immediately don't go for paging concept of OS. That is different. This is different. I think you know. Page number means here DM cache interpret main memory as group of cache memories. That individual, that single cache memory group we are calling as page here. And the drawback of DM is high conflict misses, but it takes less time to produce hit or miss because only one comparison it will do. Only one tag comparison it will do. What is the comparator, guys? Tag is called comparator. So how many comparisons you do in DM? 1. But in associative mapping, the interpretation is only tag and word, because tag is main memory block number and conflict misses are 0, hit latency is very high. So conflict misses and hit latency are interchanged by DM and AM. So if you prefer either, there is one suffering issue. To balance these two, we have got SAM, set associative mapping, where the address is interpreted as tag, set and set offset and word offset. And what is maintained as tag? From the main memory block number, if you remove LSB set bits, that remaining MSB portion is maintained as a tag by the SAM, and it balances both conflict misses and hit latency. Compared with DM, conflict misses are less. Compared with AM, hit latency is also less. Right? Then in secondary memory, we have one very important, very useful formula regarding sector number. I have given it many times in many sessions. If you have got CHS, where C is a cylinder number or track number, H is head number or surface number, S is a sector number. If you have got CHS and if you are asked to find sector number, how do you find? C into total surfaces into sectors plus H into sectors per track plus S. Guys, if you have got sector number and asking for CHS, mostly it would be MCQ. So do reverse engineering, apply this formula on every option. Which option give you your sector number, that is the answer. That is easy than applying the standard approach. If anyone know how to derive CHS if sector number is given, the standard approach, they will definitely agree with me. That is little time consuming process. So if at all it is objective MCQ, please apply formula on every option. Which option gives the given sector number, that is the answer. Okay. Ramdil, don't worry much about or don't think much about that. Just give your best, do your best. Definitely best will happen to you. Okay. Don't be afraid of the result. Give your best. That is what you have to do. Result will automatically comes. Okay. And in the secondary memory, another thing which you have to revise is regarding access time. The time to access a sector capital T is summation of seek time, rotational latency, transfer time and controller's time. Seek time to reach the track, rotational latency to position the sector, transfer time to copy data, controller's time taken by the read-write logic. And on an average 180-degree rotation is required, hence rotational latency is just half of the rotation time. Then in the pipelining we have certain formulae which are very useful, very much required for solving questions in the exam. In the pipelining, generally we take all the pipelining concept into 4 cases. One is the very base case where every instruction, every stage is taking same time. So if small t stage time is uniform, then for non-pipelined processor you will calculate the time as n into k into t, and for pipelined processor you will calculate it as n minus 1 plus k into t, where n is number of instructions, k is number of stages. Suppose if the stage time is non-uniform, every instruction, every stage is taking different time, then if you sum up all those stage times of all the instructions, you will get non-pipeline serial time. And pipelined time we rely upon space-time chart. Because small t is not generic, you have to rely on space-time chart. By drawing it, you can derive the total pipelined time. And suppose if the stage time is expressed in terms of stage delay and interstage delay, then non-pipelined stage time you calculate as summation of stage delays. Pipelined time you calculate as max of stage delay plus interstage delay. And suppose we have got a discussion of stall in the question, and it is asking to find the time with respect to stalls, then this is what you use: 1 plus stall frequency into stall duration, how long the stall exists, whole multiplied by cycle time. Along with this, when number of instructions is much bigger than number of stages, where you will get ideal speed up, that is maximum speed up, that is equal to number of stages. And efficiency is S by S max, so you can say S divided by K, or what is S, nk by n plus k minus 1 whole by k. So in this way efficiency you can calculate as n by n plus k minus 1. And throughput of the pipeline is speed up by n divided by efficiency by k, I think. Throughput, number of instructions executed in the given time or speed up achieved in the given time. So S by T, you will get efficiency divided by T. Right? And how we calculate the speed up? If stage time is uniform, you say nk by n plus k minus 1. If stage time is non-uniform, we sum up all the stage times in non-pipeline. We use space-time chart for pipeline and you do the ratio. And if you got stage delay and interstage delay, this is non-pipelined time, this is pipelined time. And finally, if you have got this stall, then k divided by the time, 1 plus stall frequency into duration, that is what you apply. Okay. And in the IO interfacing, it is possible you may need to use this aptitude kind of formula sometimes. Suppose, yeah, we know in the interleaved DMA mode, CPU and DMA controller will be sharing the bus. So when CPU is using the bus, DMA controller is idle. When DMA controller is using the bus, CPU is idle. Let X be the time CPU is using the bus, Y be the time DMA controller is using the bus. If so, what is the percentage of time CPU is idle? We can calculate it as Y divided by X plus Y into 100 as we want in percentage, and percentage of CPU busy time, you can say X divided by X plus Y, right? So I can say these are very important points of computer organization and architecture. So I have revised this PDS, algo and COA important points and formulae. Do include these and some other important points whatever you feel in your short notes. Now Murali sir will take the charge and he will be revising some other subjects. I hope Murali sir is waiting for us already. So Murali sir will take the charge now. Murali sir, over to you. Thank you guys. Prepare well, all the very best, and from tomorrow we will be taking 15 plus most important questions at 8 p.m. Do attend. Thank you sir. Over to you sir.
Thank you, Satya sir. Okay. Hello everybody. I hope you are enjoying the session of Anshul sir and also Satya sir. They have been taking the sessions so far. So now today, now I will be teaching you the important formulas for computer networks and theory of computation. So please do quickly join and mark your presence. Yes. How are you all? So I will be covering computer networks and theory of computation. So please join quickly and I will revise some of the important points of computer networks and also theory of computation. So in fact in theory of computation formulas are less but still all important things what is to be required to revise those things we will discuss. Yeah, am I audible? Is my audio video everything is fine? Yes. I hope every one of you are enjoying the session. Yes. Good evening, Kirti Kumar Singh. Saubhagya Nayak, good evening. Kaushalya, good evening. Good evening, everybody. Yes. Okay. So now let me start the session now. Just a moment. Yes. So I will begin with computer networks. So before that, you can just have a look at my profile. As some of you may be new to this session, myself Murali Krishna. I am having 21 plus years of teaching experience. These are some of my credentials of you can go through it, and these are the subjects I taught. Yes. So now please do like this session and also share with your friends so that your friends also can join. And I can say both the subjects are very important subject and equally weighted subjects. Like around 9 marks you will get from CN 9 marks and theory of computation also you will get 9 marks. You can ask your friends to join the session. So I will quickly revise both the subjects. Okay, so definitely it will be useful to you and for the revision, right? Okay, shall I start the session now? Okay, fine. Pooja, thank you. Sushma and Kaushalya, thank you very much. And whatever the doubts you will get, you can just ask me through the chat only. Yeah, so now I will begin the session. You can just see this ESE 2022 prelims revision sprint is there. These are the dates. You can just have a look at this. Okay, so now in computer networks, first I will begin with computer networks. So computer networks, IP addresses are major thing. So IP version 4 we are having in our syllabus, IPv4. In IP version 4, actually the format of IP version 4 is of 32 bits. It is shown by means of dotted decimal notation, right? So what is dotted decimal notation? So it is like this: X point, Y point, Z point, W. Okay, so this each octet is indicating the total 8 bits. Octet is nothing but it's a group of 8 bits. Yes. Yeah. Thank you, Chandan Kumar Jaiswal. So yeah. Good. So now, actually, in order to quick some of the points to remember here, class A addresses are ranging from 0 to 127 in the first byte and in the decimal, and class B 128 to 191, class C 192 to 223, 224 to 239 is class D, and 240 to 255 is class D. So the maximum value in every IP address octet is 255. And the minimum value is 0. So every octet is ranging from 0 to 255. So basing on the leftmost octet, we can identify the class of an IP address, right? Similarly, in the binary, the representation, if leftmost bit is 0, it's a class A. Leftmost bits are 1, 0 in the first byte of IP address, it is a class B. 110, it is a class C. 1110, it is a class D. And 1111, it is a class C. So very simple. You have to remember some of the things. Number of networks in class A is like 0 is fixed na? So net ID, host ID like this na? So here if you take class A, net ID is 8 bits and host ID is 24 bits. And net ID, if you fix 1 bit, then remaining 7 bits will be there. Maximum number of networks is 2 power 7 only in class A. And in class B, so 10 will be the fixed, right? So then we have remaining 14 bits will be there. 2 power 14 is the number of networks in class B. So there were some one more questions earlier asked regarding this. And in class C 110, so 3 bits are fixed out of 24 bits. Then 2 power 21 is the number of networks in class C. And class D is for multicasting purpose, and class E is reserved for the future reference. And actually, as far as the number of host IP addresses for every class A network is 2 power 24 minus 2. Please remember all these things. So 2 power 24, because we are using 3 bytes for the host ID, 2 power 24 hosts. Out of that, if all are zeros, we use for network address, all are ones, we use for the broadcast address within the network. So class A networks are very bigger in size, number of networks are very small in size, number of networks are small. And in the case of class B, host ID is 16 bits, so we can have for every class B networks 2 power 16 minus 2 is the number of hosts. And also in class C, we are having only 8 bits, and every class C network will be having 2 power 8 minus 2 is the number of host IP addresses. And class E is basically reserved for the future reference at the time of inventing these addresses. But later on, that research is also done, and also that is used by using the CIDR notations. Okay. So please do like this session and share with your friends. Yeah, if you have any doubt, you could ask me now. Yes, Naman, good evening. Yes. Yeah, please. Okay, so now in this we are going to discuss some of the important points in IP version 4. So definitely just I am dividing into 3 parts here. Okay, network layer, data link layer, and a transport layer. So this is a major portion in the computer networks. As you know, you can see all the previous gate papers also. So majority portion is covered in these 3 layers. So quickly I will revise all the things. IP addresses already I have told you. So in this you have to prepare for subnetting, supernetting, CIDR also. And one more thing here you have to understand, and you please make a note. You have to be very fast in converting decimal to binary. Okay, so then you can save your time. So most of the time the problems related to IP addresses are related to binary numbers. You have to perform mask operation and all. So better you practice that part, decimal to binary, binary to decimal. If you convert very fast, so it would be easy for you to answer the questions related to IP addresses. I hope you are following. Am I audible? Please let me know. I hope I am audible. Yes, yes. Okay. So now coming to, so public IP is nothing but the IP that is usable. See, there are private IP addresses and public IP addresses. Public IP address is nothing but it is a routable addresses. So that is in the worldwide internet. So private IP addresses are non-routable addresses. Those are in the private networks. Yes, Deepak Pandey. So that is the difference between public IP and private IP. I hope you understood. Yes, yes, Pooja. Public IP is a routable address, so that is it is a unique and universal. No two IP addresses are same in the entire world at the same time. Okay. So now in computer networks, as I told you already, so three layers are very important. One layer is network layer. In the network layer, IP version 4 header is there. So definitely you will get one question from the IP version 4 header format. So the contents of header. So it describes the total IP version 4 protocol. The header will describe the entire IP version 4 protocol. So here the payload length. So actually header is containing the control information plus data. So data is called as payload. So there are two fields, header length field is there and also total length field is there. Total length field is in the form of bytes. Header length field will be in the form of words. Actually you have to convert the words into bytes. So if you subtract the header length from the total length, you will get the payload length, right? Okay, and fragmentation offset, this is very important. Total number of bytes carried in the previous fragments divided by 8. So when there is a bigger fragment, bigger datagram, we are supposed to divide this into different smaller chunks. Okay, so every chunk is supposed to have its offset value to know the relative position in the original datagram. So for that, the first fragment will be having a fragmentation offset 0. Second fragment will be having a fragmentation offset x by 8, where x is the number of bytes carried in the previous fragment. Like that, for example, you are having three fragments, fragment 1, fragment 2 and fragment 3. So third fragment fragmentation offset is number of bytes carried in first fragment plus second fragment divided by 8. So that's what this formula says. Total bytes in all previous fragments divided by 8. And first byte ID, every fragment data, that is the payload part, will be giving some numbering, right? So the first byte always start with 0 and last byte, that depends on the length of the datagram. When it is divided into multiple fragments, so the first byte fragmentation ID will be fragmentation offset whatever is given into 8. For example, fragmentation offset is given as 100. Then the first byte ID will be 100 into 8. So that means 800 bytes of carried in the previous fragments from 0 to 799. So the right now the present fragment will be having a first byte ID as 800 and last byte ID depends on the payload length. So these three formulas are very important in order to understand the content of the header. Yes, yes, Suhas, good evening. Am I audible? Okay. So meanwhile, if you get any doubt, please do ask, and also please do like the session, share with your friends. Yes, yes. Now coming to some of the important points in this, options size in the header. Say for example, the IP version 4 header, if you consider, the compulsory size is 20 bytes. Okay, and options maximum 40 bytes. So including the compulsory field and options total, the maximum size of the header is 60 bytes. So if you wanted to know how many options are there in the header, so total header length in bytes minus 20 bytes, because 20 bytes is compulsory. So there are 5 words actually. Every word is 4 bytes. That's why 5 words is taken as 5 into 4. 20 bytes is the compulsory field. Okay, so let us suppose you are having a header length value 1100. So this is indicating 1100 is a 12. So 12 words. 12 words is nothing but 12 into 4. 48. So 48 minus 20. So 28 bytes is the options. And if you wanted to know the payload, the entire header size, both compulsory and options must be subtracted from the total length field, right? So then only you will get the option, payload length, right? Okay, now coming to the data link list. So these are the some of points, and also two more points you have to remember is the distance vector routing, DVR, distance vector routing, and also link state routing. So don't leave these two topics in the routing. So both are dynamic routing techniques, adaptive routing techniques. and comparison of distance vector link state, okay, and the complexities of all those things will be more important as far as the routing algorithms are concerned. Okay, now coming to the data link layer. Data link layer is containing two parts, right? So logical link control and also what is the other one? Medium access control. Okay, so here a sliding window protocol. So three protocols are there: stop and wait protocol, go back and protocol, and select to repeat protocol. Okay, so in a nutshell, I will tell you what are the things you have to concentrate more on this based on the previous pattern of the questions and also so many other sources. Okay, please listen carefully for this. So stop and wait protocol efficiency is equal to 1 by 1 plus 2a. So where a is the propagation time divided by transmission time. As you know, in a stop and wait protocol, every sender will send one frame and wait for the acknowledgement. After getting acknowledgement only, next frame will be sent. So that means utilization is very low. So sender is idle till acknowledgement is arrived. So that means only at the time of transmitting the data, so it is engaged. After that, so the transmission time plus 2 into propagation time. So 2 into propagation is nothing but the data frame should go from sender to receiver, and acknowledgement frame must come from receiver to sender. So for that it will take some time. So that is called propagation time. So 2 into propagation is a nu. So nu is equal to, nu is nothing but efficiency or sender's utilization or link utilization, all are same here. So this actually, when you substitute TP by TT in the place of A, you will get like this. Here acknowledgement transmission time is neglected. Please remember, acknowledgement transmission time is neglected. So most of the time acknowledgement is a control frame, so it will be having less in size, so it will be neglected. Sometimes acknowledgement transmission time also will be considered. In that case, both the things, acknowledgement transmission time and data transmission time and round trip time, all the things must be included in the denominator. So that will be easily understood based on the data given. So please remember that. Yes, are you following? Yes. No. Actually, Deepak Pandey, class A will be public IP in the sense class A is basically is a very bigger networks. Okay, so very big organizations, government organization will use the class A addresses. Okay, so please do same for civil engineering also. Yeah, Abhishek, yeah, definitely I will inform our civil engineering fellow faculty. So definitely don't worry. Yes. Okay. Now if you have any doubt, please do ask. Don't hesitate to ask your doubt. Okay. So this is the stop and wait protocol. Any doubt in the stop and wait protocol? You can ask me. So most of the time actually based on this formula, sometimes efficiency will be asked. Sometimes efficiency will be given. What should be the minimum frame size? Transmission time also will be asked. Sometimes propagation time also will be asked. So I have seen 3 different questions on this formula on the previous GATE examination papers. One question on finding the efficiency, one question on finding the minimum length of the frame, because transmission time formula, you know, length divided by bandwidth, and propagation time also will be asked, and sometimes what will be the length of the frame, what will be the distance in the network. So this type of questions are asked. So once if the formula is known to you, any type of question you can answer. Now coming to the go back and protocol. Go back and protocol, actually we can send multiple frames, as you know. So I am not discussing in detail, just I am briefing you all these things. So efficiency in a go back and protocol, we can send multiple frames in the window. Whatever the frames that are available in the sender window, all the frames can be sent without waiting for acknowledgement. So that's why the numerator will be window size. So that means transmission time of all the frames. So the sender is busy while transmitting all the frames in the window. So till you get the acknowledgement, you can keep on sending, and we can adjust the sender's window, slide the sender's window based on the acknowledgement received, and based on the frames received, receiver window can be slided. And here also A is equal to TP by TT, and W is the sender's window size. What is the receiver's window size in go back n? Can anybody tell me? What is the receiver's window size in the go back n? Sender's window size is equal to 2 power n minus 1. Here W indicates sender window. This efficiency is a sender's efficiency only. 2 power n minus 1. Okay. So this is indicating n is the number of bits used for the frame sequence number. N is the number of bits used for the frame sequence number. Number of bits used for the frame sequence number. Frame sequence number. F sequence is nothing but frame sequence number. So where A is the propagation time divided by transmission time. So sender can keep on sending the frames without waiting for acknowledgement. Am I right? Okay. So most of the questions will be based on the how many bits are required for the frame sequence number. Okay. Efficiency will be given. Indirectly transmission time and propagation time will be given. And so we need to find out the number of bits used for the frame sequence number. Okay, by taking the W is equal to 2 power n minus 1. That depends on the algorithm we use. Okay, if it is a go back n, 2 power n minus 1. If it is a selective repeat, 2 power n minus 1. Actually minus 1 is in power for the selective repeat. For the go back n, minus 1 is in base. Very simple. For example, if I am using 3 bits for the frame sequence number, okay, so the sender window size is maximum 2 power 3 minus 1. So that is a 7. Here if I am using 3 bits, so 2 power 3 minus 1, it is nothing but 4. Only 4 frames we can send without waiting for acknowledgement. Where W indicates window size, A is a propagation time divided by transmission time. So that is a selective repeat ARQ. Here also most of the questions are finding the efficiency or finding the n value. So what should be the number of bits used for the frame sequence number. So that type of questions are asked. Yeah. So please let me know if you have any doubts on this. Sir, from where we get this PDF? Definitely this PDF I will share in the Telegram group. If you are not there in the Telegram group, you can join me in the Telegram group. Exactly, Deepak Pandey. Yeah. So what is this one you are talking about? Yeah, correct. Round trip delay, round trip time are same. Yeah, round trip delay and round trip time both are same. Delay is nothing but time only, right? So both are same. It is a 2 into propagation time. So propagation time from data to transmit from A to B. Okay, and again for acknowledgement to propagate from B to A. So this is a 2 into propagation. Yes. Yeah, Akshay Kumar, Telegram group, most of you are available, right? I will share you in this. And after the session is over, we will also comment you in the comment box regarding your doubts. So please continue asking your doubts in the comment box also. Please do like the session and share with your friends once again. And in CSMA CD protocol, this is also comes under the data link layer, but it comes under medium access control. It is a sub layer of data link layer. To control the access of shared media, we use this layer, as you all know. CSMA, carrier sense multiplexes with collision detection. So these are used in the Ethernet protocols. Ethernet protocols are using the CSMA CD protocols. Okay, this is a most important formula. Majority of the questions so far on this formula. L by B is equal to 2 into D by V. So what is L by B? It's a transmission time. D by V is a propagation time. So that means the sender side, the size of the frame should be minimum, okay, of certain size actually. So you have to select the frame size in such a way that whose transmission time is equivalent to the propagation time. That means till you get the acknowledgement. Acknowledgement will come after the propagation, 2 into round trip time. After the propagation only from A to B and B to A. So 2 into propagation only you will get the acknowledgement. Till that time, if you have a data to send, so that the utilization will be better. So that's what the minimum frame size is, the maximum number of bits that can be sent in a round trip time. So what is the round trip time here? Here RTT, round trip time or round trip delay, is equal to 2 into D by V. 2 into D by V is nothing but 2 into propagation time. D by V is nothing but propagation. Propagation time is directly depending upon the directly proportional to the distance and inversely proportional to the velocity. Velocity means the signal speed in the cable of the network. Okay. So most of the questions will be maybe other 3 will be given. One thing will be asked, maybe finding the length of the frame, or finding the bandwidth by giving others, or finding the distance in kilometers, or finding the signal speed in meters per second, something like that. So measurement should be very, very important. Okay, so if length you are taking in bytes, means bandwidth also you should take in bytes. Both should be in bytes or in bits. And d by v, either both should be in kilometers or both should be in meters you have to take. For example, if they mentioned 3 into 10 power 8 meters, let us suppose. Okay, so light velocity, that is a v, and distance is given as some 2 kilometers, let us suppose. So then when you are finding this d by v, kilometers you can convert into meters, so that 2000, 1 kilometer is 1000 meters. Like that you have to do. But sometimes most of the mistakes are done by the students while calculating, even though you know this concept well, while in the calculation some mistakes are done. So that's why I'm telling you. Are you following? Any doubt is there? Please do let me know, and also share with your friends. Please do like the session. Yes, Suhas, thank you, thank you. Is it fine? Okay. Do you have any doubt on this? Okay, now as you know, L by B is a transmission time and propagation time. This propagation time formula is Tp is equal to d by v, where d is the distance. Distance means the cable length. So length of the network, 2 kilometers, 1 kilometer, like that. So v is the velocity or signal speed. Signal speed. And transmission time is based on the length of the data and bandwidth. Bandwidth is the speed of the network. So transmission time is represented with Tt. So if more length data you transmit, more time it will take. Less length data if you transmit, less time. That depends on the bandwidth also. Bandwidth is more, means the transmission time will be less. It is inversely proportional, right? Now coming to the one more important aspect of computer networks, that is a transport layer. So on these 3 layers only you will get a lot of questions. So in the transport layer, TCP protocol is very important. Okay, so like there is a policy is there in the transport layer, congestion policy. So slow start congestion policy. You have to study about the TCP header also, sequence numbers, byte IDs, special flag patterns in the TCP, and flow control, congestion control and all. But more important thing is a congestion control. So please be careful about this. A lot of confusion will be there. So you have to be very clear in your concept. Then only you can answer the questions in the transport layer. Yeah. Do you have any doubt in this? Actually, in this transport layer, the TCP provides flow control as well as congestion control. So there is a policy of congestion control. Initially, the congestion control begins with the slow start phase. In a slow start phase, the window size, sender window size will start with 1 maximum segment size. Yes, 1 maximum segment size, that is 1 MSS. So congestion window size 1 MSS. If one segment is acknowledged, then next time we can send 2 segments. If both are acknowledged, then we can send the 4 MSS of message. 4, it can be exponentially increased. Then if all are acknowledged, then window size can be 8 MSS. So for every round, the window size will be doubled. That means exponentially it will increase. 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16. So it will go to certain extent. Then after that you have to change the phase. If too many segments are sent by the sender based on the window size, okay, so definitely there is a chance for the congestion. Too many segments may arrive at a router, and a router at a router point bottleneck may form. So that leads to the discarding of some of the segments. To avoid that, the sender has to restrict itself by using this TCP policy. This is what TCP policy. This is very important. And if they wanted to twist the question, definitely they will ask on this congestion only in the transport layer especially. Okay. So there are 3 cases of detecting the 2 cases of detecting the congestion. One is a timeout, other is a 3 acknowledgements. So you have to be very clear regarding how the TCP is reacted when the timeout is occurred, and how the TCP will react when 3 acknowledgements are arrived. That is very important. This diagram is important. Initially it will begin with 1 MSS. It keep on exponential increases based on the rounds it is making, and congestion may be occurred either during slow start or maybe in other phase. Wherever the congestion is occurred, the reaction of TCP, if the congestion is detected through the timeout, and threshold value of SS slow start will be half of the present congestion window size. For example, congestion is detected when the congestion window is 10 MSS, then we will keep the SS threshold as 5 MSS. Initially at the start of the slow start also we will keep some SS threshold value like some 16 MSS or 8 MSS, that depends. And still we can keep on updating the SS threshold value based on the happenings as and when congestion is detected, etc. Are you following? For example, if congestion window is greater than or equal to SS threshold at any point of time, before that congestion is not detected, then we don't go the congestion window size beyond the SS threshold. So this is equal to SS threshold. We will make the congestion window size as SS threshold and we will change the phase. So we will move from slow start to congestion avoidance, right? So in the congestion avoidance, so when the timeout is occurred, same reaction, half of the present congestion window, and we will go back to slow start. Reaction is very severe in the case of detection through timeout. So it will go back to slow start and again begins at 1 MSS. But whereas if a congestion is detected through 3 acknowledgements, either during the slow start or during the congestion avoidance phase, so we will make the SS threshold half of the congestion window like of here, but congestion window will not go to the 1 MSS. Instead it will start with a new SS threshold value and it will continue in the congestion avoidance. This is a very important point to note down. Is it clear? And any doubt is there? Please do like this session and please share with your friends. And these are the most important points of computer networks in the transport layer and data link layer and also network layer. I have covered only very important points where frequency of the questions in the previous gate was very high. Those questions and those topics only I have just referred here. And in addition to that, some 1 mark questions in application layer, maybe network security, earlier it was there, but even if it is not there, just go through it, maybe one mark it's possible. And also you can go through the OSI reference model and all, okay, and exponential backoff algorithm, etc. Okay, so meanwhile still if you have any doubt in the preparation strategy and style, you could ask me. I'm here to help you, right? Okay, so bit buffering by example, say please. Bit stuffing, okay, bit stuffing is very simple, Kanchan. Bit stuffing is something like this. Say for example we are having 1 0 1 1 1 1 0 1 0 1 0 1, for example. This is the data I have to send. Kanchan, please listen carefully. So this data based on the flag pattern, let us suppose the flag pattern is containing the value some 0 1 1, let us suppose. Okay, so 0 1 1 1, this is the data I am talking about. This is the data and I am supposed to send this data by using bit stuffing. In a bit stuffing, starting with a flag pattern, ending with a flag pattern. This is the framing technique actually. So in the data, if at all, if 3 consecutive ones are arrived, so after every, if consecutive ones are not there or not there, after every 2 consecutive ones, exactly 3 are not required. Okay, after every 2 consecutive ones, 0 is stuffed. Say here, for example, after stuffing it would be like this. It will be sent as 1 0. Actually 4 ones are there, no? After the 2 ones, stuffing is done. Again after 2 ones, stuffing is done. Again 0, 1 0, 1 0. After 2 ones, stuffing is done. Again 1. So this is the stuffed bit, this is the stuffed bit, this is the stuffed bit, and this is 3 bits are stuffed. After every 2, if the flag pattern is containing n consecutive ones, so n minus 1 consecutive ones, after n minus 1 consecutive ones, the stuffing is done. Yes, Hiralal Kumar, Telegram link I cannot post here. So I think others are available. I think you can post. 3 acknowledgements, very simple actually. So during the slow start phase, if 3 acknowledgements are arrived, for example, so there is a weak possibility of congestion. Timeout is a strong possibility of congestion. 3 acknowledgement means maybe 1 segment is arrived, second segment is not arrived, but third segment is arrived. In that case, 3 acknowledgements will come. A reaction of TCP remains same. If congestion is detected through 3 acknowledgements, it will continue in the congestion avoidance phase by making the SS threshold value off of the congestion window and congestion window size equal to present SS threshold value. Yeah, please do like this session, every one of you, please. Yeah, I hope you understood Kanchan. Yeah, Nishat, have you understood 3 acknowledgements? Yeah, fine. So now coming to the next theory of computation. So I hope everything is clear in networks. These are the things. In addition to this, you can also follow the topics what I have just now told you for 1 mark questions. So majority of the 2 mark questions will be from these topics only. Okay. Now coming to a theory of computation. So theory of computation, as you know, it is a very tricky subject in the entire CSE, computer science and engineering. So you have to be very careful in answering the theory of computation questions. So for this, actually the main mantra for this subject, I can say practice, practice and practice. There is no other mantra for this subject. Okay. So when you close the book, everything will be new. When you open the book, you will feel everything is known to you. So till before the examination, just 1 day before exam also, this theory of computation you have to practice. Okay. So you know these are the different levels of the hierarchy of formal languages like finite state machines, DCFLs, CFLs and CSLs. Okay. Undecidable problems, not partially decidable. Okay. Partially decidable problems, all those things. So this is a Venn diagram which is indicating the relation between the different formal languages. A regular language, DCFL, CFL, CSL, recursive and recursively enumerable sets. You can just go through this diagram. And also in the regular expressions, you can see these identities, regular expressions. So definitely you will get one question from the regular expressions, maybe for 1 mark or 2 marks. Mostly it is for 2 marks regarding the comparison of expressions. So these are some basic principles in the comparison of expressions. If you know these basics, we can easily answer the questions related to these regular expressions. So a plus a is a plus epsilon is not equal to a, because two expressions are same if both the languages are same. Here two strings are there, here one string is there, that's why both are not equivalent. Like this. So a is not equal to a, epsilon dot a dot epsilon. So concatenation, any string is concatenated with epsilon means it is equal to that string. Yes, are you following? So in addition to this, you can also go through the formulas related to phi. These three are very important. I am just keeping in a box because most of the time there were questions related to equations. So something like L1 is given as phi and L2 is given as epsilon. So what is L1 union L2? That type of things. What is L1 dot L2? So when you concatenate any expression with phi, it will become phi. When you take union of phi with any other expression, that is equal to other expression. Phi star is taken as epsilon. And AB whole star gives AB sequence, BA whole star gives BA sequence, both are not equivalent, these two are equivalent. We can say that regular expression R is equivalent to regular expression S, provided if a language generated by regular expression R is the same as language generated by regular expression S. Are you following? Yeah, please do like the session and make a copy to your friends. So, hi, Kushal Agarwal, good morning. Yes, definitely. Deepak Pandey, yes. Fine. Okay. Please do like the session and share with your friends. So definitely, I will share this PDF also in the Telegram group. Those who are in the Telegram group, and others also, don't worry. Those who are not in the Telegram group right now, link I cannot share right now. So definitely, I will ensure that you will reach it. Okay. So these are the some of the identities you have to remember, so that making use of these any type of regular expression questions we can answer, I can say. And different languages, so plenty of languages you have to practice. You take for all regular languages, try to construct expressions and also finite state machine and also a conversion from NFA to DFA, all those things. And in the actually the formulas are very less, actually directly problems here. Okay. So but still there are some of the things you have to know. What type of strings are accepted by the finite state machine? L of m is nothing but language accepted by the machine. So strings like x are accepted if transition of q naught and x is in final state. So that means string is accepted, there is a path from initial state to final state. Say for example, these are the states. Okay. And we are having transitions like this, just okay. So let us suppose we are having a string like ABB. So we are started at Q0. Okay, so transition of Q0 on ABB, A goes to Q1, and B goes to Q2, and see, this is A, right? So let us take it as A, and ABA is accepted. So what is the state it is reaching? Q2. As Q2 belongs to final state, double circles is final state, it is accepted. So L of M is equal to X such that transition of Q0 on X is in final state. Then this is the string that can be included in the language of the grammar. I hope you understood. Language of the finite state machine. And equal state in the DFA. So in the minimization is very, very important. Sometimes now they used to ask whether the following DFA can be minimized or not. Okay. So two states are equivalent, two or more states. For example, state P is equivalent to state Q, which is equivalent to state R, provided if and only if. So if the condition is satisfied, transition of for all X belongs to sigma star. Sigma star means it may be any string. So over that alphabet sigma, because language is defined over the alphabet sigma. So transition of P comma X is in one state means transition of Q comma X also must be in same state in the sense either final or non-final. And transition of R comma X also must be in same state. If all these things are in a same state, then we can say that they are equivalent. So this may be different final states. Either both must be in final or both must be in different non-finals. But that should be satisfied for every string. So checking the equality for infinite strings, it is practically not possible. That's why when you are minimizing, from equivalent states we will come. So distinguishable states we will see, and then coming to the equivalent states. Yes, are you following? Any doubt is there regarding equal states? If two or more states are equivalent in the DFA, we can club them into single state. So to minimize the number of states in the DFA. And also one more thing is, one final or non-final never be equivalent. Equality may exist among only the final states, or equality may exist among only the non-final states. One final, one non-final can never be equivalent. Yes, are you following? Yeah, good. Yes. Yeah, full course marathon, Kushal, already we have done earlier. In theory of computation, Maha Marathon we have done. You can go through those videos. Actually, in theory of computation, very, very important questions are discussed. Around 25 questions covering all the syllabus is covered in Maha Marathon theory of computation. Still it is available in the YouTube. You can go through it, and in the comment box also you can ask your doubts. Still I am having an access to that. I will reply to your doubts. Okay, now coming to distinguishable. If for all X belongs to sigma star, for any X, if this condition is failed, it is distinguishable. You can see this. For example, the pair P and Q are distinguishable. Distinguishable means not equivalent. So P is not equivalent to Q, provided for any X belongs to sigma star. There is a lot of difference. Here for all X belongs to sigma star. Here for any X. Okay. If transition of P comma X is in final state means Q comma X must be non-final, or vice versa. For example, P comma X is in non-final, then Q comma X must be in final. So then we can say that it is distinguishable. So very simple. The condition failed, equal condition failed for any X is considered to be a distinguishable, right? Yeah, please do like the session, don't forget, and share with your friends still. And I'm requesting everybody to go through the Maha Marathon class sessions also, which are available in the YouTube on all the subjects. Please go through those topics. Yes. And any doubt is there? Epsilon belongs to sigma star. Exactly. Epsilon also belongs to sigma star. Deepak Pandey. Zero instance. Yes. Hi Kushal. Yeah, how are you, Kushal? Yeah. Okay, fine. Please do like this session and share with your friends. So definitely this session is going to be a revision for you to just brush out all the important points here. And as I told you, especially this type of subjects, tricky subjects, you have to be in continuous touch and continuous practice. So that is the only mantra for getting 100% marks in theory of computation. Okay, fine. And language accepted by context-free grammar. So context-free grammar or any grammar, so that is L of G. The strings must be in the form of terminals, small letters will be there. And starting symbol of the grammar should generate the W either directly or indirectly. So this is one formula. L of G is indicating language generated by grammar. For example, S derives AB. Okay, A derives small a and B derives small b. So indirectly, if you are able to generate something like S derives AB and A derives small a and B derives small b, in 3 steps I am able to get AB, which is belongs to T star terminals, and the starting symbol is able to derive. The star indicating after application of some productions, if you are able to derive the string, then it is a member. Okay, only starting symbol has to generate. If a starting symbol cannot generate, means that cannot be included in the language. Grammar is correct only if all the strings of the language are generated from the starting symbol, either directly or indirectly. If a wrong string should not be generated. Okay, fine. Yes, good. Yes, Ashu Singh, is it scheduled on 29th and 30th? No, Ashu. Actually, I am talking about already the topic which is done. Okay, 30th and 31st also scheduled on the app TOC classes, Theory of Computation. Raj Ujjwal, difference between epsilon and phi. Very good question. Epsilon is nothing but it is a null string. Okay, phi is nothing but it is a regular expression denoting the empty language, not containing any string. But epsilon is one string actually. It is a empty string, null string we can say. A string of length 0 is called epsilon. Even epsilon also not there means it is a phi. For example, you take starting state as a final, epsilon will accept, and final state is there, starting is there, no transition is there, starting also not final, it is accepting empty language, means phi. Hope you understood. That is the difference between epsilon and phi. Raj Ujjwal, have you understood? LHS having one variable and RHS having anything in CFG, exactly. So in the context-free grammar, the format will be like this. Left side is a single variable, right side can be anything. For example, Greek letter alpha I am using. Alpha can be any combination of variables and terminals. That is the rules of the context-free grammars. V indicates set of variables, T indicates set of terminals. Clear? So please do like this session, everybody. Yeah, it is okay, fine. Mathematics marathon already scheduled, right? I think. Okay, I will let you know. Now coming to next useful variable in the CFG. Useful variable means the variable must be used in the derivation of any string. For example, all the strings are generated from starting symbol. S is the starting symbol, and I wanted to check the usefulness of a variable x. X is a variable here. So whether variable x is useful or not, I am checking means. So in the derivation of string w, where w is the terminals, from the starting symbol, in the process of deriving a string w, x is also obtained. Here delta 1 and delta 2 are some sentences, like some variables and terminals combination, sentential format. Okay. Now coming to language accepted by the PDA. This is very important. There were some questions on PDA. Most of the people will get confused. We can generate a PDA or design a PDA through empty stack as well as final state. Okay. So when the string is accepted, if the resulting state is any state, but the stack must be empty. So by the time, for example, a power n, b power n. Okay, if you push a's into stack for 3 a's, for each b, we popped the a. Then you will get empty stack for 3 b's. So string is accepted. That is called empty stack. State need not be defined as a final state. It can be any state in the set of state. So Z0 is the initial stack symbol. But for the final state, okay, L of m is when the string is ended, the state what you are getting should be a final state, but the stack status, here gamma indicates stack status. It can be having any symbols in the stack, doesn't matter. It may be empty or may not be empty, but state should be final state. That's all. Is it clear? Please do like this session, share with your friends. Yes. Okay, now coming to the language accepted by the Turing machine. What do you mean by Turing machine? It is a mathematical model of a computer, you can say. So any type of language a Turing machine can accept. Type 0, type 1, type 2, type 3. All computable languages can be accepted. So Turing recognizable languages also, recursively enumerable languages also. Okay. So actually Turing machine, when it is halted, okay, so the resulting state must be final state, and on the tape we can have any combination of tape symbols, but the machine must halt with a final state. So that is like this. So Q0 and W means when you start with the initial state, after the machine has made some transitions like left to right and right to left and all, the resulting scenario on the tape should be alpha 1 P alpha 2, where P must be a final state and alpha 1 and alpha 2 must belongs to any combination of the tape symbols. So halting is important here, right? Then only the string will be accepted. Is it clear? Yeah, please share with your friends. Good evening, Jubair Ahmad, how are you? Yeah. Now, if you have any doubt or any trick you want to prepare for TOC, you can just ask me regarding your bidirectional. Movement of the Turing machine is bidirectional. Exactly, Ujjwal. Okay. Now, for undecidability, this chart in so many other classes also, I have just briefly described this. Definitely one question will come in undecidability, either for 1 mark or for 2 marks. So for any type of question, if you can by heart or if you can understand this chart, okay, easily you can answer the questions. So membership problem, S means decidable, Y means decidable here, N means undecidable, not decidable. Okay, so for DCFL, CFL, recursive and recursive enumerable sets, this for every question, whether it is decidable or not, it's mentioned here. You can just have a look at this before going to the examination. Okay, so that's all for today. I hope you have enjoyed the session, and please let me know still if you have any doubt or any concern. Yeah, PDA, yes, Ujjwal, PDA is only one direction. Turing machine only will go in two directions. Okay, PDA will go in only one direction. Finite automata goes in only one direction. A two-way finite automata goes in both the direction, but it cannot modify the symbols. Turing machine can go in both the directions and also can update the symbols. Is it clear? Okay, uh, so basically Turing machine is a powerful. So finite automata languages, push-down automata languages, linear bounded automata languages, all can be recognized. Finite automata power is less, and push-down automata is powerful than finite automata. Turing machine is more powerful than PDA and finite automata. Yes. Still, you can ask the questions, please. And in Turing machines, definitely there will be questions related to actually what is recursive enumerable, and the properties related to recursive and recursive enumerable also will be asked, and mixing of properties. For example, L1 is recursive, L2 is CFL. What is L1 intersection L2? So this type of mixing of properties don't leave any of the question. That is very easy. Okay, regular languages, almost all the properties they are closed. In contextual languages, majority of them are closed. Okay, very intersection complementation is not closed. Major usable, regularly usable properties we can study. Don't go in detail about very rare properties. Okay, so recursive properties, union, complementation, and intersection, recursive enumerable languages, Turing machine languages, push-down automata languages, comparison of finite automatas, comparison of grammars. Okay, and finding the regular expressions for a given language, and a regular expression will be given, language will be asked, DFA will be given, and the number of final states. DFA will be given, they may ask whether it is minimized or not, and for a certain language, number of final states in minimum DFA required. This type of questions are frequently asked, and in future also there is a possibility. So please prepare like that. And in computer networks, as I told you, 3 layers you concentrate much, then other layers also you can go through it, but just for 1 mark. Okay, and for this one, yes, tell me. Yes, Sambhav Jain, please someone share Telegram group link. Yeah, actually link is not shareable here. Actually we are unable to share the link. Yes, useless symbols, how to remove? Very simple. For example, you are having a grammar like this. Let us suppose S2 A or AB. Okay, and A derives AA or A, and B derives BA or AB. So first of all, you have to see, I wanted to remove the useless symbols from this. You have to see what are the variables which are directly able to derive a terminal string or indirectly able to derive a terminal string. For example, the variable A is directly able to derive a terminal string, and variable a is obtained from the starting symbol. But if you take the b is providing the productions like BA or AB. For example, if B is replaced with again BA, then B will continue, no termination for B. So even if I use the production like S to AB, there is no use. I can terminate, because every string should be from starting symbol, right? And this B will be continued if B is replaced with BA or something. So B is useless here. So all the productions connected with B I have to remove. Then what happens? The leftover will be S to A and A to AA or A. Now there is no use with A also, because S to AB production cannot be used. Then what is the use? The derivation of a terminal symbol from the A also useless, because it is connected with useless variable that has been removed. So now A also will be useless. The only useful variable is S. That's all. Like that we can remove. Yes, Suhas, can you tell some few points about undecidability table? Okay, good, definitely. So few points is like, you take any question related to regular language is decidable. Okay, and see, for example, equivalence in the sense comparison. For example, is language L1 is equivalent to language L2 if both are context-free languages. Okay, in the case of DCFL, deterministic context-free, we can decide it, algorithm is there, but whereas in the case of context-free languages which are non-deterministic, that is undecidable. Okay, membership is in the sense is the string present in the language. So in all the cases it is yes, even recursive also, because Turing machine will halt. In the recursive enumerable, it is not decidable. Like that, is a language equal to sigma star, universal language. In the case of regular and DCFL only, in the case of regular and DCFL only, it is decidable. Remaining all cases undecidable. Like that. So question is like, for any question, if you are able to say answer yes or no, it's decidable. Yes or no we can say only when there is algorithm. Algorithm is a procedure to solve the problem, right? Yes, that's all. Yeah, that's all for today. I hope you have understood the concept very well and you have enjoyed the session. Please do share with your friends, and also please do like the session, and keep attending our we are coming up with some new sessions like top important 15 questions, most important questions also we are coming up shortly. So please keep watching the sessions and attend the sessions. Please do like it and share with your friends. Thanks a lot. Thank you so much. Bye bye. See you all. Thank you. Good night. All the best.